The Pacific Ocean was named in 1520 by Ferdinand Magellan. He called it that because the waters were unusually calm when he entered it. That naming came after he had just navigated through a much more difficult stretch of water, which he had called the Stormy Straits. The contrast between the two journeys was so stark that the name for the vast calm sea simply stuck. It became a permanent label for the largest body of water on the planet. The deepest point in any ocean is the Mariana Trench, located in the western Pacific. The measurement is approximately 10,994 meters at its lowest verified point. If you placed Mount Everest at the bottom of this trench, its peak would still be more than a mile below the ocean's surface. The top of the world's tallest mountain would not even break the waterline. That is the scale of the depth involved. It is a vertical distance that is difficult to visualize. The Roaring Forties are specific latitudes in the southern hemisphere between 40 and 50 degrees south. The Furious Fifties extend from 50 to 60 degrees south. These belts have powerful westerly winds that circle the globe with almost no land to slow them down. The lack of land masses at those latitudes allows the winds to build up sustained speeds that are consistent year-round. Sailors have known these routes for centuries as efficient but challenging passages. Point Nemo is the place in the ocean farthest from any land. Its coordinates place it in the South Pacific, roughly 2,688 kilometers from the nearest shoreline. The closest humans to this location at any given time are typically on the International Space Station. They orbit overhead at a distance of about 408 kilometers, which is actually closer than any ship on the surface. It is an unusual piece of trivia about isolation. The area is so remote that it is often used as a safe zone for decommissioned spacecraft to re-enter the atmosphere. The international dateline is not a straight north-south line at all. It deviates to the east and west in several places to accommodate the political boundaries of island nations. These zigzags ensure that countries in the same archipelago operate on the same calendar day. Without these adjustments, neighboring islands would be separated by a full 24 hours. The line was drawn and redrawn primarily for convenience and trade. It is a human-made construct over the water. The Gulf Stream moves an immense volume of water northward along the eastern coast of North America. Its flow rate exceeds the combined discharge of every river on Earth. That includes the Amazon, the Nile, and all the other major river systems combined into one massive current. The stream is driven by wind patterns and the rotation of the planet. It carries warm water from the tropics toward the cooler northern latitudes. Ocean glitter is the term for the bright specular reflection of sunlight on the water's surface. This effect appears as a silvery sheen that changes with the angle of observation and the roughness of the sea. It is not the same as the blue color of the water, which is a separate optical phenomenon. Ocean glitter is purely the mirror-like reflection of the sun's rays. It is the reason the sea sometimes looks like scattered metal. The Antarctic circumpolar current flows eastward around the entire continent of Antarctica. It is the largest ocean current by volume and moves more water than any other current system. There is no land mass at those latitudes to block its path, so it circulates continuously in a loop. This current connects the Atlantic, Pacific, and Indian Oceans in a single ring of moving water. It plays a central role in distributing heat and nutrients across the global ocean. The Sargasso Sea is defined not by coastlines but by ocean currents. It sits in the North Atlantic and is bounded by the Gulf Stream, the North Atlantic Current, and other currents that form a rotating gyre. There is no land border for this sea at all. It is marked instead by the presence of free-floating sargassum seaweed, which accumulates in the calm center of the gyre. The area is like a lake within the ocean, but without shores. The word maelstrom originally referred to a specific whirlpool off the coast of Norway. This particular whirlpool forms in a narrow strait between two islands. Over time, the term was generalized to describe any powerful whirlpool or chaotic situation. The original maelstrom is still a real feature of the Norwegian coastline. It has predictable intervals tied to the tides, making it a measurable phenomenon. Zealandia is a submerged continent located southeast of Australia. Most of it is underwater, with only New Zealand and a few small islands rising above the surface. The landmass was once above water, but sank over millions of years. Geologists consider it a distinct continental fragment, rather than just a collection of islands. The recognition of Zealandia as a separate continent is relatively recent in geological terms. The Strait of Gibraltar connects the Atlantic Ocean to the Mediterranean Sea. It is only about 14 kilometers wide at its narrowest point. The water in the Mediterranean is saltier than the water in the Atlantic. This difference in salinity creates a two-layer flow. Denser Mediterranean water flows out at the bottom, while lighter Atlantic water enters at the surface. The strait is a gateway with its own internal dynamics. The study of the shape of the ocean floor is called bathymetry. It is the underwater equivalent of topography on land. The name is derived from Greek words meaning deep and measure. Early depth measurements were made with weighted lines lowered from ships. Modern bathymetry is done with sonar systems that bounce sound waves off the seabed. The maximum depth of the ocean floor is located in the Challenger Deep, within the Mariana Trench. The measured depth was first recorded in 1960 by a submersible called the Trieste. Later measurements refined that number to approximately 10,994 meters. The pressure at that depth is more than 1,000 times the standard atmospheric pressure at sea level. It is a place where only specialized vessels can reach. The Pacific Ocean is the largest of the world's 5 oceans. It covers about 63 million square miles of surface area. This is more than the total land area of every continent combined. The Pacific stretches from the Arctic in the north to the Antarctic in the south. It spans about 19,000 kilometers at its widest point. The Atlantic Ocean is the second largest and is roughly half the size of the Pacific. It covers about 41 million square miles. The Atlantic is generally shallower than the Pacific, with an average depth of about 3,300 meters. The Mid-Atlantic Ridge runs down the center of this ocean, a chain of underwater mountains that is part of a global system. The Indian Ocean is the third largest, covering about 27 million square miles. Its average depth is similar to that of the Atlantic, around 3,700 meters. The Indian Ocean is warmer than the other oceans due to its position near the equator. It is bordered by 3 continents, Africa, Asia, and Australia. The water here is generally less saline than the Atlantic because of high evaporation and less runoff. The Southern Ocean surrounds Antarctica and is sometimes considered part of the other oceans. It is the youngest officially recognized ocean, defined in the year 2000. It covers about 7.8 million square miles. The waters here are cold and rich in nutrients, supporting large populations of krill and other marine life. The ocean is characterized by the strong currents that flow around the continent. The Arctic Ocean is the smallest and shallowest of the 5. It covers about 5.4 million square miles, which is less than the area of Russia. The Arctic is partially covered by sea ice that expands and contracts with the seasons. The average depth is about 1,205 meters, making it significantly shallower than the others. The water here is cold, often below freezing point, but it does not freeze completely because of its salt content. The term meridian is used in navigation to describe lines of longitude. The prime meridian is the line that runs through Greenwich, England, and is designated as 0 degrees. It is a reference point for measuring east and west positions. This line crosses the Atlantic Ocean and passes through several countries and bodies of water. It is a purely human construct for mapping the globe. The equator is an imaginary line that circles the Earth at 0 degrees latitude. It divides the planet into the northern and southern hemispheres. The equator passes through the Pacific, Atlantic, and Indian Oceans. The water at the equator is generally warm because it receives direct sunlight throughout the year. The line is used as a reference for climate and navigation. The Tropic of Cancer and the Tropic of Capricorn are lines of latitude at approximately 23.5 degrees north and south. They mark the areas where the sun can be directly overhead. These latitudes pass through ocean waters in several regions. They are named after the constellations that were visible at the time they were defined, but they are purely astronomical reference points. The Arctic Circle and Antarctic Circle are located at approximately 66.5 degrees north and south. Within these circles, there are days when the sun does not rise and days when it does not set. The ocean waters within these circles are cold and often covered with ice. These are real geographic features with measurable seasonal effects. They are defined by the tilt of the Earth's axis. The continental shelf is the area of seabed that is shallow and close to the shore. It extends from the coastline to the continental slope, where the depth increases rapidly. The shelf is generally less than 200 meters deep. It is a rich area for fishing and underwater exploration. The width of the continental shelf varies greatly, from nearly 0 to over 1,000 kilometers. The continental slope is the transition zone from the shelf to the deep ocean floor. It is a steep incline that drops rapidly to the abyssal plain. The slope is often cut by submarine canyons that funnel sediment and nutrients into deeper waters. These canyons are similar to canyons on land but are carved by underwater currents. The slope is a boundary between the coastal zone and the deep sea. The abyssal plain is a flat region of the ocean floor that lies between 3,000 and 6,000 meters deep. These plains cover more than half of the Earth's surface. They are covered with sediment that has settled over millions of years. The plains are remarkably flat due to the gradual accumulation of material. They are the largest habitat on Earth. The mid-ocean ridge is a continuous chain of underwater mountains that stretches for about 65,000 kilometers. It is the longest mountain range in the world, far longer than any on land. The ridge system is the site of volcanic activity and seafloor spreading. New oceanic crust is created here as plates pull apart. The mountains are generally hidden beneath thousands of meters of water. The hadal zone refers to the deepest parts of the ocean, specifically the trenches and troughs. It extends from about 6,000 meters to the deepest known depth of 10,994 meters. This zone is characterized by extreme pressure and cold temperatures. Life exists here in the form of specialized organisms that have adapted to these conditions. It is the least explored part of the ocean. The continental drift theory explains how the continents have moved over geological time. The ocean floor is part of this movement, with plates sliding and colliding. The process is driven by convection currents in the Earth's mantle. This movement is slow, typically measured in centimeters per year. Over millions of years, it has reshaped the geography of the oceans. The term gyre refers to a large system of circulating ocean currents. There are 5 major gyres in the world's oceans. They are formed by the combination of wind patterns and the Earth's rotation. Each gyre is a massive, slow-moving vortex that covers thousands of square miles. The water within a gyre tends to be relatively stagnant in the center. The North Pacific Gyre is one of these major circulation systems. It moves in a clockwise direction because of the Coriolis effect in the northern hemisphere. The gyre is large, covering most of the northern Pacific. The center of this gyre is where floating debris tends to accumulate. The water moves slowly at the center, allowing plastics and other materials to concentrate. The South Pacific Gyre moves in a counterclockwise direction. It is also large and covers much of the southern Pacific. The center is similarly calm and collects floating material. These gyres are the result of consistent wind and current patterns. They are stable features of ocean circulation, defined by latitude and prevailing winds. The word ocean comes to us from the Greek term okeanos. In ancient Greek writing, this referred to the great river that was believed to encircle the known world. The term was adopted into Latin and then into English, keeping its reference to the vast body of salt water. It is simply the word we use for the great expanse of sea. The origin is purely linguistic and descriptive. The name Atlantic has a similarly straightforward origin. It derives from a term meaning the sea beyond the Atlas Mountains. The Atlas Range is located in northwest Africa, and the ocean beyond it was named accordingly. There is no mythological figure associated with this naming in the secular sense. It is a geographical reference to a mountain range that is visible from the coast. The formal study of the ocean is called oceanography. This term combines the Greek word for sea, okeanos, with the Greek word for writing, graphos. It is the science of describing and understanding the ocean's physical and biological properties. Oceanography encompasses everything from currents to marine life to the chemistry of seawater. It is a broad field with many specialized subdisciplines. The word salmon has a very specific origin that is not related to the fish itself. It comes from the Latin verb salire, which means to leap. This refers to the salmon's well-known behavior of jumping up waterfalls and rapids during their migrations. The name describes an action rather than the fish's appearance. It is an example of a word that captures a behavioral trait. Tidal is a word that is directly related to time. The root of the word connects to the concept of time, because tides were historically used as a natural clock. Coastal communities would track the regular rise and fall of the sea to mark the hours. The connection is so old that the word and the concept are nearly inseparable. It is a reminder of how the sea once governed daily schedules. The word coral entered English from the Greek korallion. This term was used for the hard, stone-like material that comes from the sea. Coral is actually the skeletal remains of tiny marine animals called polyps. The material has been collected and used for jewelry and decoration for thousands of years. The word itself is purely descriptive of the physical substance. Plankton comes from the Greek word planktos, which means wanderer or drifter. This is an accurate description of these tiny organisms, which are carried by ocean currents. They are not strong swimmers and cannot move against the flow of water. The term captures their passive nature perfectly. It is one of the most fitting names in marine biology. The term nautical traces back through Latin to the Greek nautes, meaning sailor. It is used to describe anything related to ships, navigation, and seafaring. The word evolved over centuries but kept its core association with those who travel by sea. It appears in many compounds, such as nautical mile and nautical chart. The origin is straightforward and secular. The word mermaid is a simple compound of two Old English words. Mere means sea, and maid means a young woman or girl. So a mermaid is literally a sea maid. There is no complex etymology or foreign root here. It is a very literal description of the mythical creature, with no deeper linguistic mystery. The term bay originally described the act of gaping or opening widely. Over time, it came to be applied to a body of water that opens out from the coastline. A bay is a recess in the shore, a place where the land curves inward and the water follows. The shape of a bay visually resembles the opening the word originally described. It is a word that moved from a verb to a noun. Kelp is a word that did not originally refer to the seaweed itself. In early usage, it meant the ash produced by burning seaweed, which was used in glassmaking. Over time, the term shifted to refer to the plant rather than its byproduct. The word is now synonymous with the large brown algae that grow in cold waters. It is a case of a word's meaning changing completely. The term abyss comes from a Greek word meaning bottomless. It was used to describe the deep sea, which seemed to have no floor. The word entered English through Latin and has retained its sense of depth and darkness. An abyss is a place that is deep and seemingly infinite. It is a term that evokes the mysterious nature of the deep ocean. The word current comes from the Latin currere, which means to run. It describes the movement of water as it runs through the ocean. Currents can be fast or slow, but they all flow in a particular direction. The word is also used for electrical flow, but its root is the same. It is a word about movement that is very descriptive. Wave is derived from an Old English word meaning to move back and forth. This is exactly what a wave does as it travels across the surface of the water. The word is both a noun and a verb, describing the motion itself. It is a very direct and simple term with deep roots in the language. It has remained unchanged in its core meaning for centuries. The term surface comes from the French sur, meaning above, and face, meaning the visible part. It refers to the top layer of the ocean that we can see from above. The surface is where the air and water meet, a boundary that is visible and defined. It is a word about the interface between two worlds. It is a technical term that describes a simple concept. Depth comes from an Old English word meaning deep, and it measures how far down something goes. The depth of the ocean is a key measurement in oceanography. It is a word that describes a dimension, specifically the vertical distance from the surface to the bottom. It is used in many contexts, from swimming pools to shipwrecks. It is a fundamental term for understanding the sea. The word shore comes from an Old English term meaning a piece of land. It describes the edge of the sea where the land meets the water. The shore is a transitional zone that is neither fully land nor fully water. It is a place that changes with the tides. The word has been in use for centuries in the same basic form. Coast has a similar meaning to shore, but it comes from a Latin word meaning side. The coast is the side of the land that faces the sea. It is a broader term that can refer to a larger stretch of land. The word has been used in English since the Middle Ages. It is a standard term for the area where land and sea meet. Maritime is derived from the Latin maritimus, meaning of the sea. It is used to describe anything related to the sea, from commerce to law to history. The word is formal and somewhat technical. It has a broader scope than nautical, covering all aspects of sea life and trade. It is a useful word for discussing the sea in a general sense. Navigation comes from the Latin navigare, which means to sail. It combines navis for ship and agere for to drive. Navigation is the act of driving a ship, or more broadly, the art of finding the way across the sea. The term has expanded to include air and space travel. Its root is firmly tied to the sea. The word voyage comes from the French voyage, meaning a journey. It originally referred to a journey by sea, though it now applies to long journeys by any means. The term is associated with exploration and travel. It has a romantic quality that comes from its association with long sea passages. It remains a common word for any extended trip. Port comes from the Latin portus, meaning a harbor. It describes a place where ships can dock safely. The word is also used for the left side of a ship, but that usage comes from the fact that ships used to dock on that side. The term is practical and descriptive. It has been in use for centuries without significant change. Harbor is another word for a sheltered body of water where ships can anchor. It comes from an Old English word that also meant shelter or refuge. The term suggests safety from the open sea. It has both a literal and a metaphorical meaning. A harbor is a place of protection, both in shipping and in speech. Anchor comes from a Latin word meaning hook. An anchor is a heavy hook-like device that holds a ship in place. The word is ancient and is found in many languages. It has a practical meaning, but it is also used metaphorically for anything that provides stability. The original device was a large rock, but over time it evolved into a hooked piece of metal. The keel is the central structural member of a ship, running from bow to stern. The word comes from an Old Norse term meaning a ridge or a beam. It is the backbone of the ship's frame. The keel must be strong enough to support the entire weight of the vessel. It is a word that has been in use for centuries in Northern European shipbuilding. Hull refers to the main body of the ship, excluding the masts and rigging. It comes from an Old English word meaning a shell or covering. The hull is the part of the ship that is in direct contact with the water. It is the part that provides buoyancy. The word is simple and descriptive, reflecting the shape of the vessel. The bow is the front part of the ship, from an Old English word meaning shoulder. The bow is the part that cuts through the water. It is the forwardmost point of the vessel. The word has a long history in maritime language. It remains a standard term for all seafaring vessels. The stern is the rear part of the ship. from an Old Norse word meaning the tail. The stern is the back of the vessel, the opposite of the bow. It is where the rudder is usually located. The word is consistent across many European languages. It is a basic term for ship structure. Starboard is the right side of a ship, from an Old English term meaning steering side. In the past, ships were steered with a large oar on the right side, hence the name. The left side became port, because that side was used for docking. The terms are ancient and practical. They are still in use today. A reef is a ridge of rock or coral near the surface of the water. The word comes from an Old Norse term meaning a ridge or a rib. It can be dangerous for ships because it is hidden below the surface. The term is also used as a verb, meaning to reduce the area of a sail. It is a versatile word with two distinct maritime meanings. Shoal is similar to a reef, but it often refers to a sandbar or shallow area. The word comes from an Old English term meaning shallow. It is a place where the water is not deep. Ships must be careful in shoal waters to avoid running aground. The term is very descriptive of the condition. It is a word that warns of danger. Tide comes from an Old English word meaning time. The tide is the rise and fall of the sea, and it occurs at regular intervals. The connection to time is direct, because tides are predictable and cyclical. They are the clock of the coast. The word has kept this connection for centuries, linking time and the sea in a single term. The average depth of the global ocean is approximately 3,688 meters. That is about 12,100 feet in the older system of measurement. This average takes into account the shallow continental shelves and the extremely deep trenches. It is a number that represents a midpoint between the shallowest and deepest parts of the sea. Most of the ocean floor is actually between 3,000 and 5,000 meters deep, so this average is reasonably representative of the typical depths. The longest distance ever traveled by a single ocean wave was recorded in 1960. This wave was generated by a massive earthquake off the coast of Chile. It traveled across the Pacific Ocean and was still measurable when it reached Japan and Hawaii. The distance it covered was over 16,000 kilometers. The wave moved at the speed of a jet aircraft across the open water. The Gulf of Maine experiences a specific cooling and warming pattern that creates a distinct fog belt. The water temperature changes at a rate of about 1 degree Celsius per month in certain seasons. This temperature shift causes moisture in the air to condense into fog. The fog belt is a predictable phenomenon that occurs annually. It is a precise meteorological event tied to the local water temperatures. The highest tidal range on Earth occurs in the Bay of Fundy, located in eastern Canada. The difference between high tide and low tide can be as much as 16 meters. This is equivalent to the height of a 5-story building. The water rises and falls twice each day, with a significant volume of water moving in and out. The extreme range is caused by the shape of the bay and its resonance with the tidal cycle. It takes approximately 1,000 years for a single drop of water to complete the global ocean circulation loop. This is the time required for water to travel from the surface to the deep ocean and back again. The circulation is driven by differences in temperature and salinity, a process called thermohaline circulation. The journey is slow, but it is continuous. This means that the water you see today is part of a centuries-long process. The temperature of the deep ocean, below about 1,000 meters, is universally close to 4 degrees Celsius. This is the temperature at which water is densest. The deep sea is consistently cold because it is insulated from surface warming. The temperature varies only slightly in different regions of the world. It is one of the most stable environments on the planet. On March 25, 2012, a solo submersible dive reached the bottom of the Mariana Trench at precisely 5:52 a.m. The dive was made by filmmaker James Cameron in a specially designed vehicle called the Deep Sea Challenger. The time of reaching the bottom is recorded and verified by his support team. It was the first solo dive to the deepest part of the ocean in over 50 years. The precise time of 5:52 a.m. is part of the expedition's official log. The average salinity of the ocean is approximately 35 grams of salt per liter of seawater. This number varies slightly depending on the region, with some areas being saltier and others less so. The variation is due to factors like evaporation, precipitation, and freshwater runoff. The overall average remains consistent at about 35 parts per thousand. This is one of the most basic measurements in oceanography. The fastest surface wave speed ever recorded in the Pacific was about 500 miles per hour. This occurred during a specific storm in 1935 that generated exceptionally long waves. The waves traveled at unusual speeds because of the storm's intensity and the deep water they crossed. The measurement was taken by a network of observing stations. Such high speeds are rare and are associated with extreme weather events. The oldest known tidal record is a series of observations from a Chinese port. These records date back to approximately 1000 BCE. The ancient Chinese kept careful track of the tides for navigation and fishing. These are the oldest continuous records of tidal data in existence. The observations were remarkably accurate for the time and show a clear understanding of tidal patterns. The total volume of the world's oceans is approximately 1.335 billion cubic kilometers. This is a staggering number that is difficult to visualize. The volume is so large that it contains more water than all the land above sea level could hold. It is the total amount of salt water on the planet. The measurement is calculated from detailed maps of the ocean floor and surface area. Sunlight takes about 1,000 minutes to penetrate the ocean down to the mesopelagic zone. This is the region between 200 and 1,000 meters below the surface. The light that reaches these depths is dim and mostly blue. The time is based on the speed of light and the distance it travels through the water. The 1,000-minute number is an approximation, but it illustrates the slow journey of light through the sea. The Pacific Ocean covers approximately 63 million square miles of the Earth's surface. This is more than the total land area of all continents combined. The Pacific extends from the Arctic in the north to the Antarctic in the south. It is also the widest ocean, stretching about 19,000 kilometers at its broadest point. These are the numbers that define its scale. The Atlantic Ocean covers about 41 million square miles and is the second largest. It is also the saltiest of the 5 oceans on average. The Atlantic is generally shallower than the Pacific, with an average depth of about 3,300 meters. The Mid-Atlantic Ridge runs down the center of this ocean. The ridge is about 16,000 kilometers long and is a key feature of the Atlantic floor. The Indian Ocean covers approximately 27 million square miles. It is the third largest ocean and is bounded by 3 continents. The average depth is about 3,700 meters, similar to the Atlantic. The Indian Ocean is warmer than the other oceans due to its proximity to the equator. The water temperature averages about 22 degrees Celsius at the surface. The Southern Ocean covers about 7.8 million square miles and is the youngest officially recognized ocean. It was defined in 2000 by the International Hydrographic Organization. The Southern Ocean is characterized by the Antarctic Circumpolar Current, which flows from west to east. The current is driven by the strong westerly winds that circle the continent. The ocean is cold and rich in nutrients. The Arctic Ocean covers approximately 5.4 million square miles, making it the smallest of the 5. It is also the shallowest, with an average depth of about 1,205 meters. The Arctic is partially covered by sea ice, which expands in winter and retreats in summer. The water temperature is often below freezing, but the salt content prevents it from freezing solid. The Gulf Stream transports about 30 million cubic meters of water per second. This is a flow rate that exceeds the combined discharge of all the world's rivers. The stream moves warm water from the Gulf of Mexico up the eastern coast of the United States. It then crosses the Atlantic toward Europe. This massive flow is one of the key drivers of the climate in the North Atlantic. The Kuroshio Current in the Pacific is similar in scale to the Gulf Stream. It flows from the Philippines past Japan and into the North Pacific. The current carries warm water northward at a rate of about 20 million cubic meters per second. It is one of the major currents of the Pacific. The Kuroshio is known for its clear blue water and its role in regional climate. The California Current flows southward along the western coast of North America. It is a cold current that brings nutrient-rich water to the surface. The current moves at a much slower speed than the Gulf Stream, about 1 kilometer per hour. It supports a large and diverse marine ecosystem. The current is driven by the prevailing winds and the rotation of the Earth. The Humboldt Current, also known as the Peru Current, flows along the western coast of South America. It is a cold current that originates from the Southern Ocean. The current is rich in nutrients and supports one of the world's largest fisheries. The water is cold because it comes from the deep ocean. The current is an important feature of the Pacific coast of South America. The Agulhas Current flows along the eastern coast of South Africa. It is a warm current that moves southward from the Indian Ocean. The current is narrow and fast, reaching speeds of up to 5 knots. It is one of the strongest currents in the world's oceans. The Agulhas Current eventually meets the cold waters of the Atlantic, creating a turbulent mixing zone. The Benguela Current flows northward along the western coast of southern Africa. It is a cold current that comes from the Southern Ocean. The current supports a productive upwelling zone that is rich in fish and other marine life. The water is cold and nutrient-dense. The Benguela Current is a key feature of the Atlantic coast of Africa. The Canary Current is a cold current that flows southward along the western coast of North Africa. It is part of the North Atlantic Gyre. The current is relatively slow but persistent. It brings cooler water to the region, affecting the local climate. The Canary Current is named after the Canary Islands, which are located near its path. The North Equatorial Current flows west across the Atlantic, near the equator. It is driven by the trade winds and moves in a broad, slow stream. This current is part of the larger North Atlantic Gyre. The current moves at about 1 knot, which is slow by ocean standards. It is a consistent and predictable flow. The South Equatorial Current flows west across the Atlantic, south of the equator. It is a counterpart to the North Equatorial Current. The current is driven by the trade winds and moves in a steady stream. The water is warm and moves across the basin. It is one of the key currents of the Atlantic. The thermohaline is a specific layer in the ocean where the temperature drops rapidly with depth. It is located between the warm surface water and the cold deep water. The thermohaline is typically found between 200 and 1,000 meters below the surface. This layer is a barrier to vertical mixing. It is one of the most important features of ocean stratification. The pycnocline is a layer where the water density changes rapidly with depth. It is often associated with the thermocline because changes in temperature affect density. The pycnocline is a barrier to mixing, keeping the surface water separate from the deeper water. It is a feature of all the world's oceans. The stability of this layer varies with seasons and location. The halocline is a layer where the salinity changes rapidly with depth. This layer is often found near the surface, where freshwater runoff mixes with seawater. The halocline can be a barrier to mixing, similar to the thermocline. It is a feature of areas with high freshwater input, such as near large rivers or in the Arctic. The depth of the photic zone is about 200 meters, the maximum depth where sunlight can penetrate. Below this depth, there is not enough light for photosynthesis. The photic zone is where most marine plants and algae live. It is the most productive part of the ocean. The zone is defined by the amount of light, which is a measurable factor. The aphotic zone is the region below 1,000 meters, where no sunlight reaches. This is the dark part of the ocean, where life relies on other sources of energy. The aphotic zone accounts for the majority of the ocean's volume. It is a cold, dark environment with very high pressure. The life here is adapted to the extreme conditions. The ocean floor covers about 70% of the Earth's surface. This means that most of the planet is covered by water. The percentage is measured in square miles. The ocean floor is as varied as the land above the water, with mountains, valleys, and plains. The total area is approximately 140 million square miles. The total number of islands in the Pacific Ocean is estimated to be over 25,000. This includes islands of all sizes, from small atolls to large landmasses. The number is approximate because new islands can form from volcanic activity. The Pacific has more islands than any other ocean. The islands are scattered across the vast expanse of the ocean. The United Nations Convention on the Law of the Sea is the primary legal framework for the world's oceans. It defines that a coastal nation has sovereignty over the waters within 12 nautical miles of its shore. Beyond that, the exclusive economic zone extends 200 nautical miles from the coast, granting rights to resources in that area. This zone is about 370 kilometers from the shore. The convention was adopted in 1982 and has been ratified by most countries. In international waters, which are beyond any nation's exclusive economic zone, the legal jurisdiction of a ship is determined by its country of registration. This is the principle of the flag state, meaning the ship is subject to the laws of the nation whose flag it flies. This rule applies regardless of where the ship is located. It is a long-standing principle of maritime law. The system allows for order on the high seas. The first successful transatlantic telegraph cable was laid in 1866. This followed several failed attempts in 1857 and 1858. The cable was laid by the ship the Great Eastern, which was the largest vessel of its time. The successful connection allowed messages to be sent between Europe and North America in minutes instead of weeks. The cable was a major achievement of 19th century engineering. The distress signal SOS was officially adopted in 1906. It was chosen not because it stands for anything specific, but because it is easy to remember and transmit. The letters S and O in Morse code are 3 dots, 3 dashes, and 3 dots, which is a simple pattern to recognize. The signal was adopted at the International Radio-Telegraphic Convention. It replaced other signals like CQD. The rule of the road for ships is a set of navigation rules that includes the right-of-way provisions. One of the basic rules is that a vessel must give way to any boat approaching on its starboard side. This is the side that is on the right when looking forward. The rule prevents collisions at sea. It is one of the oldest and most fundamental rules of navigation. There is a specific international treaty that limits the use of whale oil for industrial purposes. The treaty, part of the International Convention for the Regulation of Whaling, sets quotas and restrictions. Whale oil is still used in small quantities for certain specialized applications. The treaty aims to conserve whale populations. It has been in effect since 1946. The Cape of Good Hope was originally named the Cape of Storms by the Portuguese explorer Bartolomeu Dias. He sailed around it in 1488 and encountered rough seas. The King of Portugal renamed it the Cape of Good Hope to suggest that it was a gateway to the riches of India. The name change was a marketing decision. The original name reflects the difficulty of the passage. The HMS Challenger expedition is considered the first major scientific expedition dedicated to oceanography. It sailed from 1872 to 1876 and covered nearly 70,000 miles. The expedition conducted depth soundings, collected water samples, and discovered thousands of new species. It laid the groundwork for modern oceanography. The data collected is still used today. There is an international regulation that specifically bans the dumping of plastic waste at sea. This regulation was enacted in 1988 as part of the MARPOL Treaty. The ban is designed to protect marine life from the harmful effects of plastic pollution. Ships are required to dispose of their waste on land. The regulation is enforced by flag states. The oldest known navigational chart of the Pacific dates to the early 1500s. It was drawn by a Spanish cartographer based on the voyages of Spanish explorers. The chart shows the coastlines of the Pacific and the routes taken by early ships. It is a valuable historical document. The chart was drawn before many Pacific islands were discovered. The thermometer used by early scientists to measure deep-sea temperature was a simple device with a tube that would break at depth. The thermometer was designed so that the mercury would break and seal off, preserving the reading. The device was lowered to the desired depth and then retrieved. The reading was recorded when the thermometer was brought back to the surface. This crude method was used for decades. Maritime law makes a legal distinction between flotsam and jetsam. Flotsam is unintentional debris that is lost from a ship. Jetsam is material that has been intentionally thrown overboard, often to lighten the ship in an emergency. The distinction is important for salvage rights and property claims. It is a term that has been part of maritime law for centuries. The International Maritime Organization is a specialized agency of the United Nations. It was established in 1948 to regulate shipping and maritime safety. The organization sets standards for ship design, crew training, and environmental protection. It is responsible for the International Convention for the Safety of Life at Sea. The IMO has over 170 member states. The Suez Canal opened in 1869 and was a major shortcut for sea travel. The canal connects the Mediterranean Sea to the Red Sea, allowing ships to avoid the long route around Africa. The canal is about 193 kilometers long. It is one of the most important waterways in the world. The canal has been expanded and deepened over the years. The Panama Canal opened in 1914 and connects the Atlantic and Pacific Oceans. The canal saves ships from having to sail around the southern tip of South America. The canal is about 82 kilometers long and uses a system of locks to raise and lower ships. It is a key route for global trade. The canal is still operated today by the Panama Canal Authority. The Strait of Hormuz is a narrow strait between the Persian Gulf and the Gulf of Oman. It is about 33 kilometers wide at its narrowest point. The strait is a key shipping route for oil and natural gas. It is one of the most important choke points in the world's maritime network. The strait is located between Iran and Oman. The Strait of Malacca is a narrow passage between the Malay Peninsula and the island of Sumatra. It connects the Indian Ocean to the South China Sea. The strait is about 800 kilometers long and 65 kilometers wide at its narrowest point. It is one of the busiest shipping lanes in the world. The strait is a key route for trade between East Asia and the Middle East. The Northwest Passage is a sea route through the Arctic Ocean that connects the Atlantic and Pacific Oceans. The passage is ice-covered for much of the year and is only navigable during the summer months. The route is named after the explorers who sought it for centuries. It is a shorter route between Europe and Asia. The passage is of growing interest due to melting sea ice. The concept of the high seas is defined as the waters beyond the exclusive economic zone. These waters are open to all nations for navigation, fishing, and research. The high seas cover about half of the Earth's surface. The principle of freedom of the high seas has been a part of international law for centuries. It allows unrestricted passage outside of national waters. The International Seabed Authority was established in 1994 to regulate mining on the seabed beyond national jurisdiction. The authority is responsible for issuing licenses for the exploration and extraction of minerals. The seabed is rich in metals like nickel and cobalt. The authority is based in Jamaica. It ensures that seabed mining is carried out in an orderly manner. The concept of the innocent passage is a legal term in maritime law. It allows ships to pass through a country's territorial waters without interference, as long as the passage is continuous and expeditious. The ship must not engage in any activities that are not directly related to navigation. The right of innocent passage is enshrined in the law of the sea. It is a fundamental principle of maritime navigation. The term treaty port refers to a port that was open to foreign trade by treaty. These were common in China in the 19th century. The treaties allowed foreign ships to enter and trade in these ports. The system was eventually abolished. The term is a historical footnote in the history of maritime commerce. The phrase flags of convenience refers to the practice of registering a ship in a country with less strict regulations. The ship then flies the flag of that country. The practice allows ship owners to avoid higher taxes and stricter safety standards. It is a controversial aspect of maritime law. The term has been used since the mid-20th century. The term privateer refers to a ship that is privately owned but is authorized by a government to attack enemy ships. This practice was common in the 16th to 19th centuries. Privateers were issued letters of marque, which made their actions legal. The practice was abolished by international law. The term is now only historical. The term ballast water refers to the water taken on by a ship to maintain stability. The water is pumped into ballast tanks and discharged at the destination. This practice can introduce invasive species to new environments. The problem has been recognized for decades. There are now regulations governing the management of ballast water. The term fishing rights refers to the legal right to fish in certain waters. These rights are often granted by coastal states to other nations. Fishing rights are a key part of international negotiations. The rights are limited to specific species and quotas. The system is designed to prevent overfishing and ensure sustainability. The term maritime boundary refers to the line that separates the waters of different nations. These boundaries are determined by international law and are often based on equidistance principles. The boundaries can be disputed, and disputes are settled by negotiation or international courts. The boundaries are important for resource rights and navigation. The term salvage refers to the right to claim compensation for saving a ship or its cargo. The law of salvage is one of the oldest branches of maritime law. The reward is based on the value of the property saved. The law encourages people to assist ships in distress. It is a legal principle that has been in use for centuries. The term harbor dues refers to the fees that ships pay to use a port. These fees cover the use of the harbor and its facilities. The fees vary by port and ship size. They are a source of revenue for port authorities. The dues are part of the cost of operating a ship. The term logbook is the official record of a ship's voyage. The logbook contains information about the ship's course, speed, and position. It is a legal document that is required by law. The logbook is used for navigation and for legal purposes. The term has been in use for centuries. The term sea lane refers to a designated route for ships. These lanes are used to organize traffic and prevent collisions. The lanes are often separated by direction of travel. The system is used in busy shipping areas. The lanes are marked on nautical charts. The term roadstead refers to an area where ships can anchor, but it is not a harbor. The anchorage is protected from wind and currents. Roadsteads are often located outside of harbors. They are used as temporary waiting areas for ships. The term is an old one, but it is still used in maritime navigation. The sea otter is one of the few marine mammals known to use tools. They use rocks to crack open the shells of clams and other hard-bodied prey. The otter floats on its back and places the rock on its chest, then repeatedly pounds the shellfish against it. This behavior is specific to the species and is learned, not instinctive. The sea otter is the only member of the weasel family that is fully aquatic, and its tool use has been extensively documented by marine biologists. The blood of the horseshoe crab is a distinctive blue color. This is due to the presence of hemocyanin, a copper-containing protein that carries oxygen. Hemocyanin turns blue when it is oxygenated, unlike the iron-based hemoglobin in human blood. The horseshoe crab is not a true crab at all. It is more closely related to spiders and scorpions. The blue blood is harvested for use in medical testing, specifically for detecting bacterial toxins. A scallop has approximately 200 small eyes located along the edge of its shell. Each eye is a simple structure that can only detect light and dark, not images. The eyes are arranged in a row and are tiny, about 1 millimeter in diameter. They are used to sense movement and shadows, helping the scallop escape from predators. The scallop's vision is very limited but functional. Starfish do not have blood in the way that vertebrates do. They use seawater as a circulatory fluid, pumping it through their bodies. The water is drawn in through a structure called the madreporite and circulated through the water vascular system. This system is unique to echinoderms and is used for locomotion and feeding. The starfish's body is entirely dependent on seawater. The lungfish is an unusual fish that can survive out of water. It does so by burrowing into mud and breathing air through a modified swim bladder. The swim bladder functions like a primitive lung, absorbing oxygen from the air. The lungfish can remain in this dormant state for months, waiting for the water to return. This adaptation is found in several species of lungfish in Africa, South America, and Australia. The ocean sunfish, or mola mola, holds a record for fecundity. A single female can lay up to 300 million eggs at one time. This is more than any other vertebrate animal. The eggs are tiny and are released into the water in large numbers. The vast majority of the eggs will not survive to adulthood, but the sheer number ensures that at least some will. The sunfish is also the heaviest bony fish in the world. The exact color of a lobster's shell is determined by a specific pigment molecule that is not stable. The pigment is a type of carotenoid that is stored in the shell and bound to proteins. When the lobster is cooked, the proteins break down and the pigment turns from dark blue-green to bright red. The change in color is a physical reaction, not a biological one. The lobster's shell color varies with diet and environmental factors. Dolphins use specific whistles to identify themselves. Each dolphin has a unique whistle, which is essentially its name. This whistle is used to communicate with other dolphins and to announce its presence. The whistle is developed early in life and remains constant. It is a signature call that is recognized by the rest of the pod. The oldest known sea turtle fossil is dated to approximately 120 million years ago. This makes sea turtles one of the oldest surviving groups of reptiles. The fossil was found in Brazil and shows that early sea turtles were similar in appearance to modern species. They have survived multiple mass extinctions. The sea turtle's body plan has remained largely unchanged for millions of years. A male seahorse carries the eggs in a specific pouch called the brood pouch. This is a specialized structure located on the male's abdomen. The female deposits the eggs into the pouch, and the male fertilizes them. The male then carries the eggs until they hatch. This is the reverse of the usual pattern in the animal kingdom. The clam has a simple nervous system, but it lacks a brain. Its nervous system consists of a network of nerve cells that coordinate its basic functions. The clam can react to stimuli, but it cannot process complex information. It is a simple animal with a very basic anatomy. The clam is one of the most common creatures on the ocean floor. The exact speed of a migrating eel has been tracked across the Atlantic. European eels migrate to the Sargasso Sea to breed, a journey of over 5,000 kilometers. They are known to travel at a speed of about 25 kilometers per day in the open ocean. This speed is relatively slow for a fish. The route and speed are tracked using electronic tags. The mantis shrimp has a club-like appendage that accelerates with the speed of a bullet. The appendage is used to strike prey with incredible force. The speed of the strike is about 50 miles per hour, and it generates a powerful shockwave. The mantis shrimp uses this weapon to break open the shells of crabs and mollusks. The strike is one of the fastest movements in the animal kingdom. The sea cucumber breathes through its anus. It draws water into its respiratory tree, which is a branching structure in its body cavity. The water is then expelled, and the process is repeated. This is the primary method of respiration for the sea cucumber. It is a unique adaptation that is found only in this group of animals. The vampire squid does not suck blood. It gets its name from its dark webbing and large eyes, which give it a vampiric appearance. The vampire squid is a small, deep-sea species that is found in the oxygen minimum zone. It is not aggressive and feeds on marine snow, the decaying organic matter that falls from the surface. Its appearance is deceptive. The lanternfish makes up about 65% of all deep-sea fish biomass. This means that it is one of the most abundant fish in the world. The lanternfish is small, usually only a few inches long. It is named for the light-producing organs on its body. The fish is a key part of the deep-sea food web. The parrotfish produces sand from the coral it eats. The parrotfish scrapes coral with its beak-like teeth and digests the soft tissue. The hard calcium carbonate skeleton is then ground up and expelled. A single parrotfish can produce hundreds of pounds of sand per year. This is a major source of the sand on tropical beaches. The hagfish can produce slime that expands to 10,000 times its original volume in a fraction of a second. The slime is released from pores on the hagfish's body and is used for defense. The slime is thick and sticky, clogging the gills of predators. The hagfish is also notable for its lack of a jaw and its ability to tie itself into knots. The barrel-eye fish has a transparent head. The head is filled with a clear jelly-like substance that allows the fish to see through its own skull. The fish's eyes are located inside the transparent shield and can rotate to look upward. The barrel-eye was first described in 1939. It is a deep-sea fish that is rarely seen by humans. The sea urchin uses its spines for locomotion and protection. The spines are attached to the urchin's test, or shell, by movable joints. The urchin moves slowly across the sea floor, using its spines and tube feet. It has no brain to coordinate these movements. The spines are sharp and can be poisonous in some species. The nudibranch is a sea slug that stores the stingers of its prey for its own defense. The nudibranch feeds on hydroids, which are small, stinging animals. The stinging cells are passed through the digestive system and stored in the tips of the nudibranch's skin. The stinger is then used to deter predators. The nudibranch is brightly colored, advertising its toxic defense. The yeti crab farms bacteria on its hairy claws. It lives near hydrothermal vents, where bacteria are abundant. The crab uses its claws to filter the water and feed on the bacteria. The bacteria are cultured on the crab's hairy appendages and then consumed. The yeti crab was first discovered in 2005, making it a relatively recent discovery. The cookie-cutter shark leaves a specific circular wound on its prey. The shark uses its suction cup-like lips to attach to the skin of larger animals. It then rotates its body and cuts a circular plug of flesh with its sharp teeth. The wound is distinctive and is a signature of this small shark. The cookie-cutter shark is only about 20 inches long, but is a formidable predator. The blue whale's tongue weighs as much as an elephant, about 2,700 kilograms. The tongue is a massive organ that is used to scoop up krill. The blue whale feeds on tiny shrimp-like animals and filters them through baleen plates. The tongue is proportional to the whale's enormous size. The whale itself can weigh up to 200 tons. The sperm whale is the largest toothed predator on Earth. It feeds on deep-sea squid and other large prey. The sperm whale is known for its massive head, which contains a large oil-filled organ. The oil was highly prized by whalers. The sperm whale can dive to depths of over 2,000 meters, making it one of the deepest diving mammals. The orca, or killer whale, is the largest member of the dolphin family. It is a highly social animal that lives in pods. Orcas have a diverse diet and are known to hunt in coordinated groups. They are found in all oceans, from the Arctic to the Antarctic. Their black and white coloration is distinctive and is part of their identity. The beluga whale is known for its white color and its melon, a rounded structure on its forehead. The melon is used for echolocation, allowing the beluga to navigate and hunt in dark, murky waters. The beluga is a social animal that lives in groups and is found in the Arctic and subarctic. It is a vocal animal, making a wide range of sounds. The narwhal is a species of whale with a long, spiral tusk. The tusk is actually an elongated tooth that is found only in males. The tusk can grow up to 3 meters in length and is used for display and possibly for sensing the environment. The narwhal is found in the Arctic Ocean. The tusk makes it one of the most distinctive whales. The walrus is a large marine mammal with long tusks and prominent whiskers. The tusks are used for fighting and for hauling out onto ice. The walrus feeds on clams and other shellfish, using its sensitive whiskers to locate prey. It is found in the Arctic and subarctic seas. The walrus is a species of the family Odobenidae. The manatee is a slow-moving marine mammal that is found in the coastal waters of the Americas. It feeds on seagrasses and other plants. The manatee is often called a sea cow. It is a herbivore with a simple digestive system. The manatee is endangered in many parts of its range. It is a gentle animal that is vulnerable to boat strikes. The dugong is similar to the manatee, but is found in the Indo-Pacific region. It feeds on seagrasses and is closely related to the manatee. The dugong has a more streamlined body and a tail with distinct flukes. It is also a herbivorous mammal. The dugong is listed as vulnerable due to habitat loss. It is one of the few marine mammals that eat only plants. The sea lion is a pinniped that is found in the coastal waters of the Americas. It has external ear flaps, unlike the true seals. The sea lion is a social animal and is often seen in large groups. It feeds on fish and other marine animals. The sea lion is a skilled swimmer and is often found in zoos and aquariums. The fur seal is a pinniped that is similar to the sea lion but has a thicker coat of fur. The fur was highly prized for its warmth and softness. The fur seal was hunted extensively in the 19th century and is now protected. It is found in the Southern Ocean and the North Pacific. The fur seal is a distinct species of the family Otariidae. The ocean is home to a vast diversity of animals, from the smallest plankton to the largest whales. The creatures of the sea are adapted to a wide range of habitats, from the surface to the deep ocean floor. Their specific behaviors and physical characteristics are the result of millions of years of evolution. These are the quiet denizens of the deep. The mid-ocean ridge system is a continuous chain of underwater mountains that spans the entire globe. It stretches for approximately 65,000 kilometers, making it the longest mountain range on Earth. The ridge system is the site of volcanic activity and seafloor spreading, where new oceanic crust is created. The mountains are formed as tectonic plates pull apart, allowing magma to rise and solidify. Most of the ridge is hidden beneath thousands of meters of water, but parts of it rise above the surface in places like Iceland. The Sulu Sea, located in the western Pacific, has a specific internal wave pattern that is visible from space. These internal waves occur below the surface, traveling along the boundary between layers of different density. They are so large that they cause surface temperature variations that can be detected by satellites. The waves are generated by tidal flows through the narrow straits that connect the sea to the surrounding oceans. The Sulu Sea is a well-studied site for these internal wave phenomena. The abyssal plains are flat areas of the ocean floor that are covered with a thick layer of sediment. They are located between 3,000 and 6,000 meters below the surface and cover more than half of the Earth's surface. The plains are remarkably flat because they have been filled in by sediment over millions of years. They are often called the deserts of the deep because of the sparse life found there. The sediment comes from the gradual settling of particles from the upper ocean. Seamounts are underwater mountains that rise at least 1,000 meters from the ocean floor. They are typically of volcanic origin and are found in all the world's oceans. Seamounts are important habitats for marine life, as they create upwellings of nutrient-rich water. They are often the sites of rich fishing grounds. Many seamounts are extinct volcanoes that were formed at mid-ocean ridges and have since moved away. The Ring of Fire is a path along the Pacific Ocean that is characterized by active volcanoes and frequent earthquakes. It is a horseshoe-shaped zone that extends from New Zealand to the coast of South America. The Ring of Fire follows the boundaries of several tectonic plates. It contains about 75% of the world's active volcanoes. The region is one of the most geologically active areas on Earth. The specific mineral composition of the ocean floor is largely basalt, a dark volcanic rock. The continental crust, on the other hand, is composed mainly of granite, a lighter rock. Basalt is formed from the cooling of magma that rises at mid-ocean ridges. The difference in composition affects the density of the two types of crust. Oceanic crust is denser than continental crust, which is why it sits lower in the Earth's mantle. The Bermuda Triangle is not a recognized geographic feature by any official cartographic organization. It is not marked on any nautical chart, nor is it defined by any international body. The area is roughly bounded by Bermuda, Florida, and Puerto Rico. The reported disappearances in the region have been largely debunked. The Bermuda Triangle is more a cultural phenomenon than a scientific one. A tsunami is created by the displacement of a large volume of water, usually from an earthquake. The wave travels at a specific speed that is determined by the depth of the water. In the deep ocean, a tsunami can travel at speeds of up to 500 miles per hour. The wave is very small in the open ocean, but it grows in height as it approaches shallower water near the coast. This is what makes tsunamis dangerous when they reach land. The Pacific Plate is moving northwest at a speed of about 7 centimeters per year. This is a typical rate for tectonic plate movement. The Pacific Plate is one of the largest plates on Earth and is responsible for much of the geology of the Pacific Ocean. Its movement is driven by convection currents in the Earth's mantle. The plate is slowly being subducted beneath other plates, creating the deep trenches of the Western Pacific. Hydrothermal vents exist only in specific zones near tectonic plate boundaries. They are found along mid-ocean ridges and in areas of volcanic activity. The vents release superheated water that is rich in minerals and chemicals. The water can reach temperatures of up to 400 degrees Celsius. The vents are home to unique ecosystems that rely on chemosynthesis, not photosynthesis, for energy. The specific gravity of seawater is higher than that of fresh water. This means that seawater is denser than fresh water, which allows ships to sit higher in the water. The specific gravity of seawater is about 1.025, compared to 1.0 for fresh water. The difference is due to the salt content of seawater. This property is why it is easier to float in the ocean than in a lake. The calcium carbonate compensation depth is the specific depth at which calcium carbonate dissolves faster than it accumulates. Below this depth, the shells of calcium carbonate secreting organisms dissolve. The depth varies by region, but it is typically around 4,000 to 5,000 meters. This is why coral reefs and other calcareous structures are found only in shallower waters. The compensation depth is a key factor in the geology of the ocean floor. The global ocean floor covers about 140 million square miles of the Earth's surface. This is more than 70% of the total surface area of the planet. The floor is as varied as the land above the water, with mountains, valleys, and plains. The geology of the ocean floor is studied using sonar, seismic surveys, and deep-sea drilling. The research has revealed the dynamic nature of the Earth's crust. The continental shelf is the area of seabed that is shallow and close to the shore. It extends from the coastline to the continental slope, where the depth increases rapidly. The shelf is generally less than 200 meters deep. It is a rich area for fishing and underwater exploration. The width of the continental shelf varies greatly, from nearly 0 to over 1,000 kilometers. The continental slope is the transition zone from the shelf to the deep ocean floor. It is a steep incline that drops rapidly to the abyssal plain. The slope is often cut by submarine canyons that funnel sediment and nutrients into deeper waters. These canyons are similar to canyons on land, but are carved by underwater currents. The slope is a boundary between the coastal zone and the deep sea. The hadal zone refers to the deepest parts of the ocean, specifically the trenches and troughs. It extends from about 6,000 meters to the deepest known depth of 10,994 meters. This zone is characterized by extreme pressure and cold temperatures. Life exists here in the form of specialized organisms that have adapted to these conditions. It is the least explored part of the ocean. The continental drift theory explains how the continents have moved over geological time. The ocean floor is part of this movement, with plates sliding and colliding. The process is driven by convection currents in the Earth's mantle. This movement is slow, typically measured in centimeters per year. Over millions of years, it has reshaped the geography of the oceans. The subduction zone is a region where one tectonic plate is forced beneath another. These zones are found around the edges of the Pacific Ocean and are responsible for the deep trenches. The subducted plate melts and is recycled into the Earth's mantle. This process creates volcanic activity on the overlying plate. Subduction zones are one of the most geologically active areas on Earth. The divergence zone is a region where tectonic plates are moving apart. This occurs at mid-ocean ridges, where new oceanic crust is formed. The process is called seafloor spreading. The new crust moves away from the ridge over time. Divergence zones are also sites of volcanic activity and hydrothermal vents. The transform boundary is a region where tectonic plates slide past each other horizontally. This type of boundary is found along faults like the San Andreas Fault. In the ocean, transform boundaries connect segments of mid-ocean ridges. They are the sites of frequent earthquakes. The movement is typically slow but can be sudden. The ocean floor is not flat but is covered with features like hills, mountains, and plains. The topography is studied using a variety of methods, including sonar and satellite altimetry. The maps of the ocean floor are less detailed than those of the land. This is because the ocean is largely unexplored. The topography is a key factor in ocean currents and marine life. The mantle is the layer of the Earth below the crust. It is composed of solid rock that can flow slowly over long periods. The mantle is the source of the magma that forms new oceanic crust. The heat from the Earth's core drives the convection currents in the mantle. This is the engine of plate tectonics. The Earth's crust is the outermost layer of the planet. It is divided into two types, oceanic and continental. The oceanic crust is thinner and denser than the continental crust. It is composed primarily of basalt. The continental crust is thicker and less dense, composed of granite. The differences in composition are due to the processes of melting and differentiation. The lithosphere is the rigid outer layer of the Earth, comprising the crust and the upper mantle. It is broken into tectonic plates that move across the surface. The lithosphere is about 100 kilometers thick on average. It is the layer that is responsible for the movement of continents. The lithosphere is cool and rigid compared to the underlying asthenosphere. The asthenosphere is the layer of the Earth below the lithosphere. It is composed of hot, partially molten rock that can flow slowly. The asthenosphere is the source of the convection that drives plate tectonics. It is the layer on which the lithospheric plates move. The asthenosphere is ductile and allows the plates to slide over it. The term tectonic comes from the Greek word for builder. It is used to describe the processes that shape the Earth's crust. The study of tectonic plates is a fundamental part of geology. Tectonic processes are responsible for earthquakes, volcanoes, and the formation of mountains. The movement of plates is a slow but powerful force. The term geology comes from the Greek words for earth and study. It is the science of the earth, including its structure, composition, and history. Geology includes the study of the ocean floor, which is part of the Earth's crust. The field is vast and covers everything from volcanoes to fossilized organisms. Geologists study the processes that have shaped the planet. The term magma refers to the molten rock that is found beneath the Earth's surface. When magma reaches the surface, it is called lava. Magma is the source of volcanic activity. It is formed in the mantle and rises through the crust. The composition of magma determines the type of volcano that is formed. The term sediment refers to particles of rock and organic matter that settle to the ocean floor. The sediment can come from erosion of the land or from the remains of marine organisms. The sediment is deposited in layers over time. These layers can be studied to understand the history of the ocean. The sediment provides a record of past conditions. The term fossil refers to the remains or traces of ancient organisms. Fossils are found in the layers of sediment on the ocean floor. They provide evidence of the history of life on Earth. The study of fossils is called paleontology. Fossils from the ocean floor have revealed the evolution of marine life. The term strata refers to the layers of sediment and rock that are found on the ocean floor. The strata are deposited over time and can provide a chronological record. The study of strata is called stratigraphy. The layers can be used to date geological events. The ocean floor is a rich source of information about Earth's history. A rogue wave is defined as a wave that is more than twice the significant wave height of the surrounding sea. These waves were once dismissed as sailors' tales and were not taken seriously by the scientific community. They are now known to be real and have been measured by instruments on ships and oil platforms. Rogue waves are unpredictable and can appear suddenly in the open ocean. They are a genuine hazard to shipping and are studied to improve maritime safety. The red tide is not always red in color. It is a specific bloom of algae that can turn the water green, brown, or even purple. The color depends on the species of algae that is blooming and the pigments it contains. The term is used for any algal bloom that causes discoloration of the water. Some red tides produce toxins that are harmful to marine life and humans. The blooms are a natural phenomenon that has been observed for centuries. The specific wind speed required to create whitecaps on the ocean surface is generally around 10 knots. This is the speed at which the wind is strong enough to break the surface tension of the water and produce foam. Whitecaps are the visible sign of the transfer of energy from the air to the sea. The number of whitecaps increases with wind speed. They are a common feature of the ocean surface. The morning glory cloud is a rare wave cloud that forms over the Gulf of Carpentaria in northern Australia. It is a long, rolling cloud that can stretch for up to 1,000 kilometers. The cloud is a type of roll cloud, which is a formation that results from atmospheric waves. The morning glory is not a purely oceanic phenomenon, but it occurs over the water. It is a spectacular and unusual cloud formation. The sea surface temperature in the Pacific is monitored continuously to predict the start of specific weather cycles. The temperatures are measured by satellites and buoys. The data is used to forecast events like El Niño and La Niña. These cycles have a significant impact on weather patterns around the world. The monitoring is a key part of climate science. The specific pressure difference between the eye of a hurricane and its surroundings determines its intensity. The lower the pressure in the eye, the stronger the storm. The pressure difference drives the winds that spiral inward toward the center. Hurricanes are measured on the Saffir-Simpson scale, which is based on wind speed. The pressure is a key parameter in forecasting hurricane strength. St. Elmo's fire is a weather phenomenon that appears as a blue or violet glow on ship masts and other pointed structures during thunderstorms. It is caused by a strong electric field in the atmosphere, which creates a plasma discharge. The glow was often interpreted by sailors as a good omen, but it is a purely physical phenomenon. The discharge is harmless and is similar to the glow seen in neon lamps. It is named after Saint Erasmus, but the phenomenon itself is purely electrical. The specific height of a wave is measured from its trough to its crest, not from the mean sea level. The trough is the lowest point of the wave, and the crest is the highest point. The measurement is called the wave height. This is the standard method used in oceanography and meteorology. The height is one of the key parameters in describing wave conditions. Swell refers to a group of waves that have traveled far from their original source. These waves are generated by distant storms and can travel thousands of miles across the ocean. Swell waves have a specific period, which is the time between successive crests. They are more regular and organized than wind waves. Swell is a sign of distant weather and is important for surfing. The fetch is the distance of open water over which the wind blows in a consistent direction. The fetch determines the size of the waves that are generated. A longer fetch allows the waves to grow larger. The fetch is a key factor in wave prediction. It is measured in kilometers and is specific to the local conditions. The specific frequency of a wave is measured in hertz, which is cycles per second. The frequency is the inverse of the period. A wave with a period of 10 seconds has a frequency of 0.1 hertz. Frequency is used to describe all types of waves, from sound to light. It is a fundamental measurement in physics. The brine pool is a specific area of highly concentrated salt water that sits on the ocean floor like a lake. The water is so salty that it is denser than the surrounding seawater and does not mix with it. Brine pools are found in the Gulf of Mexico and other areas with salt deposits. They are toxic to most marine life, but some organisms can survive in the margins. The pools are a unique feature of the deep ocean floor. The sea surface is the interface between the ocean and the atmosphere. It is a critical boundary for the exchange of heat, gases, and momentum. The surface is constantly in motion, with waves, currents, and tides. It is the part of the ocean that is most directly affected by the weather. The sea surface is a dynamic and ever-changing environment. The ocean is the primary driver of the global climate. It stores and transports heat and influences weather patterns around the world. The ocean's surface temperature is a key factor in the formation of storms and the distribution of rainfall. The sea surface is a critical component of the Earth's climate system. It is a vast and powerful influence on the planet's weather. The term sea state refers to the general condition of the sea surface, including wave height, period, and direction. It is a standardized description used in marine forecasts. The sea state is classified on a scale from calm to violent. The Beaufort scale is a common method of describing sea state. It is used by sailors and meteorologists. The Beaufort scale is a measure of wind speed based on observed sea conditions. It was developed in 1805 by Francis Beaufort. The scale ranges from 0, calm, to 12, hurricane. Each force level corresponds to a specific wind speed and sea condition. The scale is still used today in maritime communications. The term storm surge refers to the rise in sea level caused by a storm. The surge is caused by the wind pushing water toward the shore and the low pressure of the storm. The surge can be several meters high and is the most damaging aspect of a hurricane. It is a major hazard for coastal communities. The surge is a temporary phenomenon that subsides after the storm passes. The term wave train refers to a group of waves that travel together. The waves are generated by the same wind event and have similar characteristics. A wave train can travel long distances across the ocean. The train is a recognizable set of waves. The term is used in both oceanography and physics. The term crest refers to the highest point of a wave. The crest is the part of the wave that is above the mean water level. The distance between crests is the wavelength. The crest is the visible top of a wave. It is the point where the wave is highest. The term trough refers to the lowest point of a wave. The trough is the part of the wave that is below the mean water level. The distance between troughs is also the wavelength. The trough is the depression between two crests. It is the lowest point of the wave. The term amplitude refers to the height of a wave from its mean position. It is half the wave height. The amplitude is a measure of the wave's energy. A larger amplitude means more energy. The amplitude is used in many areas of physics. The term wavelength refers to the distance between two consecutive crests or troughs. It is a measure of the wave's size. The wavelength determines the wave's speed in deep water. Longer wavelengths travel faster. The wavelength is a key parameter in wave mechanics. The term period refers to the time it takes for two consecutive crests to pass a fixed point. The period is measured in seconds. It is the inverse of frequency. The period is a measure of the wave's rhythm. It is used to describe all types of waves. The term frequency refers to the number of waves that pass a fixed point in a given time. It is measured in hertz. The frequency is the inverse of the period. A higher frequency means more waves per second. It is a fundamental measurement of wave motion. The term refraction refers to the bending of waves as they pass from one medium to another. In the ocean, waves refract as they approach the shore and interact with the seafloor. This process causes waves to align with the coastline. It is a key factor in coastal erosion and sediment transport. The phenomenon is also observed in light and sound. The term diffraction refers to the spreading of waves as they pass through an opening or around an obstacle. In the ocean, waves diffract around islands and through narrow passages. The diffraction pattern is visible in the way waves wrap around an obstacle. It is a fundamental property of all wave motion. The term interference refers to the interaction of two or more waves. The waves can add together constructively, creating larger waves, or cancel each other out destructively. Interference is a wave phenomenon. It is observed in the ocean as patterns of waves crossing. The term dispersion refers to the separation of waves by their speed. In the ocean, longer waves travel faster than shorter waves. This causes waves to spread out as they travel. Dispersion is a key factor in wave propagation. It is a characteristic of all wave systems. The term swell is a specific type of wave that has traveled far from its source. Swell waves are more regular and have a longer period than wind waves. They are a sign of distant storms. The swell is a common feature of the ocean surface. The ocean surface is a dynamic and ever-changing environment. It is influenced by the weather, the tides, and the currents. The surface is the part of the ocean that is most accessible to humans. It is a source of beauty and a place of work. The surface is the gateway to the deep ocean. The Great Pacific Garbage Patch is not a solid island of trash floating on the surface. It is a region of high-density microplastics suspended in the water column. The area is estimated to be roughly twice the size of Texas, but the concentration of plastic is not visible from above. Most of the debris consists of tiny fragments that are mixed throughout the water. The patch is a diffuse region rather than a concentrated mass. The oldest known shipwreck ever discovered was found off the coast of Turkey and dates to about 1300 BCE. The wreck is from the Late Bronze Age and contained a cargo of copper and tin ingots. The ship was about 15 meters long and sank in a storm or due to an accident. The discovery was made in 1982 by a team of archaeologists. It is one of the oldest intact shipwrecks in the world. A specific type of algae called fouling organisms grows on the hulls of ships and increases drag by a measurable percentage. The growth can reduce a ship's speed and increase fuel consumption by up to 40%. The algae attaches to the surface and creates a rough texture that disrupts the flow of water. This is why ships are regularly cleaned and coated with anti-fouling paint. The process of biofouling is a constant challenge for maritime operations. The bottle post was a method of sending messages in sealed bottles that were thrown into the sea. One message is known to have traveled for 98 years before it was found. The bottle was released in 1914 as part of a scientific experiment and was recovered in 2012. The message was a postcard with a request to record the location of the find. It is one of the longest journeys of a message in a bottle. The specific dye used for naval uniforms, known as navy blue, was chosen for its ability to hide stains. The dark color is practical for sailors who work with coal, grease, and other materials that leave marks. The color was also chosen for its professional appearance. Navy blue has been the standard color for naval uniforms since the 19th century. The choice was purely functional and aesthetic. The ballast in a ship is often made of a specific type of heavy rock that is sometimes ejected into the sea. The rock is taken on board to stabilize the ship and is often from the port of origin. When the ballast is discharged, it can alter the local geology by introducing non-native rocks to the seafloor. This practice is less common now, as ships use water ballast. However, the historical impact is still visible in some areas. The first submarine used in combat was the Turtle, which was used in 1776 during the American Revolutionary War. The submarine was a one-person vessel made of wood and brass that was operated by hand. It attempted to attach a mine to a British warship but failed to sink its target. The Turtle is remembered as the first military submarine. It was not successful in its mission. The SS Central America was a ship that sank in 1857 during a hurricane off the coast of the Carolinas. It was carrying tons of gold from the California gold rush. The gold was recovered in 1987 by a salvage company in a major deep-sea recovery operation. The shipwreck is known as the Ship of Gold. The recovery of the gold was a significant event in maritime archaeology. The specific sound of a ship's horn is governed by international regulations on frequency and duration. The horn must produce a sound that is audible at a specific distance and frequency. The regulations are set by the International Maritime Organization. The horn is a safety device used for signaling in fog and at night. The sound is standardized to avoid confusion. The radar technology used to find ships is the same technology that can measure sea surface roughness. The radar sends out a pulse of radio waves and measures the return signal. The return signal is affected by the surface of the water. This allows the radar to detect both the ship and the sea conditions. The technology is used in both navigation and oceanography. The paint used on the hull of modern ships is designed to be toxic to organisms that attach themselves. The paint is a specialized anti-fouling coating that prevents marine growth. The coating is applied in layers and can be very expensive. The paint is designed to slowly release biocides that prevent attachment. It is a necessary part of ship maintenance. The Titanic's distress call used the code CQD, which was later replaced by SOS. The code was used in the early days of wireless telegraphy and was a standard distress signal. The Titanic used CQD as well as the newer SOS signal. The older code is a historical footnote in the story of the ship's sinking. The switch to SOS was not yet universal at the time. Shipping containers are often lost at sea during storms or accidents. The number of containers lost each year is estimated to be over 1,000, though the exact figure varies. The containers can carry a wide variety of cargo and can float for a period of time. They are a hazard to navigation and can wash up on beaches. The loss is a factor in maritime safety and insurance. The ocean is a repository of objects lost from ships, from cargo to personal items. The items can remain on the seafloor for centuries. Some are recovered by archaeologists, while others are lost forever. The ocean floor is a vast graveyard of ships and their contents. The objects are a record of human activity at sea. Ghost nets are fishing nets that have been lost or abandoned in the ocean. They continue to trap marine life and are a form of pollution. The nets are made of synthetic materials that do not degrade quickly. They can drift for decades and entangle fish, dolphins, and sea turtles. Ghost nets are a serious environmental problem. Ocean plastic is one of the most common objects found in the sea. The plastic takes many forms, from bags to bottles to microplastics. The plastic does not biodegrade, but breaks down into smaller pieces. The pieces are ingested by marine life and can cause harm. Plastic pollution is a global concern. The seafloor is littered with debris from human activity, including shipwrecks, cargo, and trash. The debris is distributed unevenly, with some areas more affected than others. The debris can provide habitat for marine life or cause damage. The study of seafloor debris is part of oceanography. Wrecks on the seafloor can become artificial reefs. The structure of the wreck provides a hard surface for marine life to attach to. The wreck can support a diverse ecosystem. Many shipwrecks have become popular dive sites. The wrecks are a part of the ocean's ecosystem. The ocean has been used as a dumping ground for centuries. The practice has led to pollution and damage to the ecosystem. Dumping of waste is now regulated by international law. The ocean is no longer considered a convenient place to dispose of waste. Marine debris is a problem that affects all the world's oceans. The debris can come from ships, land-based sources, or natural events. The debris can travel long distances on ocean currents. It is a global issue that requires international cooperation. The objects that drift in the ocean tell a story of human activity. They are a record of trade, travel, and waste. The objects are a part of the ocean's history. The sea is a place where things are lost and sometimes found. The drift of objects is a part of the ocean's constant motion. The Mary Rose was a warship that sank in 1545 during a battle with the French fleet. She went down in the Solent, a strait between the Isle of Wight and the mainland of England. The ship was raised in 1982 in a major salvage operation that captured the public's attention. The recovery revealed thousands of Tudor-era artifacts, including personal items and weapons. The Mary Rose is now on display in a dedicated museum in Portsmouth. The Vasa was a Swedish warship that sank on its maiden voyage in 1628. The ship was launched, sailed for about 1,300 meters, and then capsized in Stockholm harbor. It was recovered nearly intact in 1961 after more than 3 centuries on the seabed. The ship was remarkably well preserved because the cold, brackish waters of the Baltic Sea prevented wood-boring organisms from destroying the hull. The Vasa is now housed in a museum in Stockholm and is one of the best preserved ships of its era. The Lusitania was a British ocean liner that sank in 1915 after being torpedoed by a German submarine. The sinking occurred off the coast of Ireland and resulted in the loss of over 1,100 lives. The wreck now rests in about 90 meters of water and is protected by the Irish government. The site is considered a war grave and is not open to recreational divers. The wreck was discovered in 1935 and has been the subject of numerous surveys. The Bismarck was a German battleship that sank in 1941 after a battle with British naval forces. The ship was discovered in 1989 by an expedition led by Robert Ballard. The wreck rests at a specific depth of approximately 4,791 meters in the North Atlantic. The wreck is in a remarkable state of preservation, with much of the hull still intact. The discovery was a significant event in maritime archaeology. The Endurance was the ship of the explorer Ernest Shackleton, which sank in 1915 after being crushed by ice. The ship went down in the Weddell Sea, off the coast of Antarctica. The wreck was only found in 2022, more than a century after it was lost. The ship sits at a depth of about 3,008 meters, remarkably well preserved in the cold Antarctic waters. The discovery was a major achievement in underwater exploration. The specific number of shipping containers lost at sea each year is estimated to be over 1,000. The exact figure varies from year to year and is difficult to track precisely. The containers are lost during storms, collisions, or other accidents. They can carry a wide variety of cargo and can float for a period of time. The containers are a hazard to navigation and can wash up on beaches far from where they were lost. The Atocha was a Spanish galleon that sank in 1622 off the coast of Florida. The ship was carrying a specific cargo of silver, emeralds, and other treasure from the New World. The wreck was discovered in 1985 after a long and expensive search. The recovery of the treasure was a major event in maritime salvage. The Atocha is one of the most famous treasure wrecks in history. The oldest intact shipwreck in the world was found in the Black Sea in 2018. The wreck is a Greek trading vessel that dates to approximately 400 BCE. The ship is so well preserved because the water at the bottom of the Black Sea is anoxic, meaning it contains no oxygen. This prevents the wood from decomposing. The wreck is a remarkable example of ancient shipbuilding. The specific material used to preserve wooden hulls in museums is a water-soluble wax called polyethylene glycol, or PEG for short. The wax is used to replace the water in the wood, preventing it from shrinking and cracking as it dries. The process can take years and is very expensive. The technique was developed in the mid-20th century and is used on many historic shipwrecks. It has allowed for the preservation of ships like the Vasa and the Mary Rose. The Insomnia was a passenger ferry that sank in 1994 in the Baltic Sea. The sinking was one of the deadliest maritime disasters in European waters. The exact cause of the sinking is still debated in maritime circles. The wreck is protected by international law and is considered a grave site. The disaster was the subject of a major international investigation. The Andrea Gale was a fishing vessel that was lost in the North Atlantic in 1991. The ship was the subject of the book and film The Perfect Storm. The ship disappeared with all 6 crew members and was never found. The exact fate of the vessel remains unknown. The story of the Andrea Gale has become a modern maritime legend. The Pioneer was the first submarine to be used for salvage operations. The submarine was used in the 1850s to recover cargo from sunken ships. The Pioneer was built in the United States and was a precursor to modern submersibles. The submarine was not a military vessel, but was used for commercial purposes. It represents an early step in the development of underwater technology. The RMS Titanic sank in 1912, after striking an iceberg on its maiden voyage. The wreck was discovered in 1985 by a joint American-French expedition. The wreck is located about 3,800 meters deep in the North Atlantic. The site is protected by international law and is considered a grave site. The discovery of the Titanic was a major event that captured the world's attention. The HMS Erebus and HMS Terra were ships from the Franklin expedition that disappeared in the Arctic in the 1840s. The wrecks were discovered in 2014 and 2016, respectively. The ships are remarkably well preserved in the cold Arctic waters. The discovery of the wrecks solved a long-standing mystery of polar exploration. The sites are now protected and studied by archaeologists. The SS Edmund Fitzgerald sank in 1975 during a storm on Lake Superior. The ship disappeared with all 29 crew members. The wreck was discovered in 1976 and is now protected by the Canadian government. The sinking was the subject of a famous song by Gordon Lightfoot. The site is considered a grave site and is not open to divers. The CSS Hunley was the first submarine to sink a warship in combat. The submarine sank the USS Housatonic in 1864 during the American Civil War. The Hunley itself was lost after the attack and was discovered in 1995. The wreck was raised in 2000 and is now on display in South Carolina. The Hunley is a significant piece of naval history. The warships of the Spanish Armada were lost in 1588 during an attempt to invade England. Many of the ships sank off the coast of Ireland. The wrecks have been the subject of extensive archaeological study. The artifacts recovered from these ships are now in museums. The wrecks are a part of maritime history. The Swedish warship Kronan sank in 1676 during a battle in the Baltic Sea. The wreck was discovered in 1980 and has been the subject of extensive archaeological work. The ship was the flagship of the Swedish Navy. The recovery of artifacts has been a major undertaking. The Kronan is one of the most important wrecks in Scandinavian history. The Dutch East India Company, or VOC, lost many ships during its operations. The VOC was one of the most powerful trading companies in history. The ships were lost in accidents and storms around the world. Many of the wrecks have been discovered and studied by archaeologists. The VOC wrecks are a significant part of maritime history. The coastline of South Africa is littered with shipwrecks. The area is known as the graveyard of ships. The wrecks date from the 16th century to the present day. The wrecks are a part of the region's history and have been studied by archaeologists. The ships were lost in storms and accidents along the treacherous coast. The ocean floor is a vast museum of shipwrecks and other objects. The wrecks are a record of human activity at sea. The study of these wrecks is called maritime archaeology. The wrecks provide information about trade, technology, and history. The ocean is a repository of the past. The term million comes from an Italian word meaning big thousand. The Italian word milione was used to describe a large thousand, or 1,000 thousands. The term was adopted into English from French. It is a purely numerical term with no mythological or historical figure attached to it. The word simply denotes a specific quantity. The term billion was originally used in French to mean a million. This was the original definition in the short-scale system. The American shift changed the meaning to 1,000 million. The difference between the short and long scales has caused confusion for centuries. The word is now used in its American sense in most English-speaking countries. The name Atlantic was used by the ancient Greeks to mean the sea beyond the Atlas Mountains. The Atlas Range is a mountain range in northwest Africa. The name is a geographical reference to a specific place. There is no reference to any mythological figure in the secular origin of the name. It is simply a label for the ocean that lies beyond those mountains. The name Pacific is simply derived from the word for peaceful. The name was given by Ferdinand Magellan because the waters were calm. The word has Latin roots and is purely descriptive. The name reflects the conditions that Magellan encountered. It is a straightforward label for the ocean. The word sargo is a term for a specific type of fish. The term comes from the Latin word for a kind of fish. It was originally just a fisherman's term for a common catch. The word has no deep etymology or historical significance. It is a simple name for a marine creature. The littoral zone refers to the area of the shore that is closest to the water. The term comes from the Latin word for shore. It is a geographical term used to describe the intertidal area. The zone is important for marine life and for coastal management. The word is purely descriptive of a location. The pelagic zone refers to the open sea, away from the shore and the sea floor. The term comes from the Greek word for sea. It is used to describe the water column and the organisms that live there. The word is purely descriptive of a zone of the ocean. It is a common term in marine biology. The term coral comes from a Latin word that also meant bead. The word refers to the shape of the coral skeleton. The Latin word corallium was used for the red coral that was prized in jewelry. The word is purely descriptive of the material. It is a secular term with a straightforward origin. The word beach likely comes from the Old English word for bank or shore. The word is of Germanic origin. It has been used in English for centuries to describe the sandy or pebbly shore. The word is purely descriptive of a landform. It is a common word for a familiar place. The term harbour comes from an Old English word meaning army or war. The word originally meant a place of shelter or refuge. A harbour is a place where ships can find shelter from the sea. The word has a long history in the English language. It is a practical term for a place of safety. The word cove comes from an Old English word meaning cave. A cove is a small, sheltered bay. The word describes the shape of the inlet, which resembles a cave. The word is purely descriptive of a landform. It is a common term for a small bay. The term wrack is used to describe seaweed that is washed up on the shore. The word comes from the Dutch word for wreck. It refers to the debris that is cast up by the sea. The term is also used for the kelp that is collected for fertilizer. The word is purely descriptive of the material. The term sound is used to describe a long, relatively narrow body of water. The term comes from the Old Norse word for strait. It is used for passages between islands or between an island and the mainland. The word is purely descriptive of a geographic feature. It is a common term in coastal geography. The term bay originally meant to gape or open widely. The word described the act of opening the mouth. The term was then applied to a body of water that opens out from the coastline. The shape of a bay visually resembles the opening. It is a word that moved from a verb to a noun. The term gulf comes from the French word for bay. It is used to describe a large bay that is partially enclosed by land. The term is also used for the body of water that separates two land masses. The word is purely descriptive of a geographic feature. It is a common term for a large bay. The term strait comes from the Latin word for narrow. It is used to describe a narrow passage of water that connects two larger bodies of water. The term is purely descriptive of a geographic feature. It is a common term for a narrow waterway. The word is often used in navigation. The term channel comes from the Latin word for pipe. It is used to describe a body of water that connects two larger bodies of water. The term is used for the English Channel and other waterways. The word is purely descriptive of a geographic feature. It is a common term for a passage of water. The term current comes from the Latin word for to run. It is used to describe the movement of water in the ocean. The term is also used for the flow of electricity. The word is purely descriptive of movement. It is a common term in oceanography. The term tide comes from the Old English word for time. The word refers to the rise and fall of the sea that occurs at regular intervals. The word connects the movement of the sea to the passage of time. The term is purely descriptive of a natural phenomenon. It is a common word for a predictable event. The term wave comes from the Old English word for to move back and forth. It is used to describe the surface of the sea. The term is also used for other types of waves, such as sound waves and light waves. The word is purely descriptive of motion. It is a common word for a familiar phenomenon. The term dock comes from the Dutch word for a basin for ships. It is used to describe a place where ships are loaded and unloaded. The term is also used for the area where ships are repaired. The word is purely descriptive of a structure. It is a common term in maritime commerce. The term keel comes from an Old Norse word for a ridge. It is the central structural member of a ship's hull. The word is used for the backbone of the ship. It is a key part of shipbuilding. The term is a practical one with a straightforward origin. The term rudder comes from the same root as row. It is a flat piece of wood or metal that is used to steer a ship. The rudder is attached to the stern and is moved by the helm. The word has a long history in maritime language. It is a practical term for a key part of a ship. The term mast comes from the Old English word for pole. It is a tall, upright pole that supports the sails. The mast is a key part of a ship's rigging. The word has a long history in maritime language. It is a practical term for a part of a ship. The term sail comes from the Old English word for cloth. It is a piece of fabric that catches the wind and propels the ship. The word has a long history in maritime language. It is a practical term for a part of a ship. The word is used for both the cloth and the act of traveling by ship. The term rigging refers to the system of ropes and chains that support the sails. The term comes from the Old Norse word for to bind. The rigging is a key part of the ship's equipment. The word has a long history in maritime language. It is a practical term for a ship's equipment. The term helm refers to the steering gear of a ship. The word comes from the Old English word for to cover. The helm is used to control the direction of the ship. The word has a long history in maritime language. It is a practical term for a key part of a ship. The term anchorage refers to the place where a ship drops anchor. The term is used for both the action and the location. The word has a long history in maritime language. It is a practical term for a place of safety. The word is used for both the act and the place. The term berth refers to a place where a ship is moored. The word comes from the Old English word for to bear. The berth is a place for a ship to rest. The word has a long history in maritime language. It is a practical term for a docking place. The term quay refers to a structure on the shore for loading and unloading ships. The word is of French origin. It is a structure that is built along the water's edge. The word is used in many coastal cities. It is a practical term for a key part of a port. The ocean has its own language, with words that have evolved over centuries. The names of the sea and its features are rooted in the practical needs of sailors and traders. The etymology is a map of the history of seafaring. The names are a record of how people have interacted with the sea. The words are a part of the ocean's story. The word ballast comes from a Middle Low German term meaning bear load. The term originally referred to a load that was carried for stability rather than for profit. The word was adopted into English from Dutch. The ballast is a key part of a ship's operation. The word is purely descriptive of its function. It is a practical term with a straightforward origin. The word barge originally described a specific type of boat, a flat-bottomed vessel used for carrying cargo on rivers and canals. The word came to be used as a verb meaning to move clumsily, like a barge moving through the water. The shift from noun to verb is a common pattern in English. The word is rooted in the practical language of water transport. It is a versatile term with a clear nautical origin. The word boy comes from the same root as the word boy, which originally meant a servant or a young male. The buoy is a floating marker that serves as a guide or a warning. The word is of Dutch and French origin. The buoy is a simple but essential piece of maritime equipment. The word is purely descriptive of its function. The word pier comes from a Latin word meaning to make solid. The pier is a structure that is built out over the water. The word entered English from French. The pier is a key part of a port. The word is practical and descriptive. It has a long history in maritime language. The word rudder comes from the same root as the word row. The rudder is a flat piece of wood or metal that is used to steer a ship. The rudder is attached to the stern and is moved by the helm. The word has a long history in maritime language. It is a practical term for a key part of a ship. The word connects the act of steering to the act of rowing. The word skipper comes from the Dutch word schipper, meaning a shipman or a captain. The term was adopted into English in the 15th century. The skipper is the person who is in charge of a boat. The word is a common term for the captain of a small vessel. It is a practical term with a Dutch origin. The word spray originally meant a twig or a branch. The word was later used for the scattering of water, as the spray from the sea. The connection is that spray appears like the fine branches of a twig. The word is purely descriptive of the appearance. It is a word that moved from a physical object to a natural phenomenon. The word tack, as in sailing into the wind, comes from the same root as attach. The tack is the maneuver of turning a ship's bow into the wind. The term is also used for the rope that attaches the sail to the ship. The word is rooted in the practical language of sailing. It is a term that has multiple meanings in maritime use. The word trim, for adjusting the sails, comes from the Old English word trimmen, meaning to strengthen or make firm. The term is used for the adjustment of the sails to the wind. The word is also used for the balance of the ship. The term has a practical origin. It is a word that has been used for centuries. The word wake, as in the ship's wake, comes from the Old Norse for a track of water. The wake is the visible track of disturbed water that a ship leaves behind it. The word is purely descriptive of a phenomenon. It is a common term for the trail of a ship. The word has a long history in maritime language. The word yacht comes from a Dutch word meaning hunt. The word originally referred to fast pursuit ships used by the Dutch Navy. The term later came to describe pleasure craft. The word is a loanword from Dutch. It is a term for a specific type of vessel. The word's origin reflects the speed of these ships. The word dock comes from the Dutch word dok, meaning a basin for ships. The dock is a structure that is built to hold water for the loading and unloading of ships. The word is also used for the area where ships are repaired. It is a practical term with a Dutch origin. The word is a key part of maritime vocabulary. The word reef comes from an Old Norse word meaning a ridge. The reef is a ridge of rock or coral near the surface of the water. The term is also used as a verb, meaning to reduce the area of a sail. The word has two distinct maritime meanings. Both meanings are rooted in the practical language of the sea. The word shoal comes from the Old English word for shallow. The shoal is an area of shallow water. The term is used for sandbars and other areas where the depth is limited. The word is purely descriptive of a condition. It is a term that warns of danger to navigation. The word cordage refers to the ropes and lines used on a ship. The word comes from the French word for rope. The cordage is a key part of a ship's equipment. The word is used for all the ropes on a vessel. The term is a practical one with a straightforward origin. The word bit comes from the Old English word for a beam. The bit is a post on a ship used for securing ropes. The term is used for the posts on the deck. The word is a practical term with a long history. It is a key part of the ship's equipment. The word block comes from the Dutch word for a pulley. The block is a device used to change the direction of a rope. The term is used for the pulleys on a ship. The word is a practical term with a nautical origin. It is a key part of the ship's rigging. The word cleat comes from the Old English word for a wedge. The cleat is a piece of wood or metal used to secure a rope. The term is used for the fastenings on a ship. The word is a practical term with a long history. It is a key part of the ship's equipment. The word hose refers to the part of the ship's bow where the anchor cables pass through. The word comes from the Old Norse word for a hole. The hose is a key part of the ship's anchoring system. The word is a practical term with a nautical origin. It is a key part of the ship's vocabulary. The word lanyard comes from the French word for a strap. The lanyard is a rope used to secure something on a ship. The term is also used for the cord that holds a whistle or a knife. The word is a practical term with a nautical origin. It is a key part of the ship's equipment. The word mizzen refers to the mast at the stern of a ship. The word comes from the Italian word for the middle. The mizzen is a key part of the ship's rigging. The term is used for the aft mast on a three-masted vessel. The word has a practical origin. The word poop refers to the stern of a ship. The word comes from the Latin word for the stern. The poop is the highest deck at the back of the ship. The term is also used for the cabin at the stern. The word has a long history in maritime language. The word scupper refers to a hole in the side of a ship that allows water to drain off the deck. The word comes from the Old French word for to spout. The scuppers are a key part of the ship's drainage system. The word is a practical term with a nautical origin. The word swab refers to a mop used to clean the deck. The word comes from the Dutch word for a mop. The swab is a key tool on a ship. The word is also used as a verb, meaning to clean. The term is a practical one with a nautical origin. The word topside refers to the part of the ship that is above the waterline. The word is a compound of top and side. The topside is the part of the ship that is visible above the water. The term is a practical one in maritime vocabulary. It is a simple descriptive term. The word underway refers to a ship that is moving. The word comes from the Dutch word for under the way. The term means that the ship is in motion and not anchored or moored. The word is a practical term in navigation. It is a key concept in maritime operations. The word waypoint refers to a specific point on a navigational route. The word is a compound of way and point. The waypoint is a reference point for navigation. The term is used in both maritime and aviation contexts. It is a practical term in modern navigation. The language of the sea is a rich and varied collection of terms. The words reflect the history of seafaring and the practical needs of sailors. Many of the terms have been in use for centuries. The language is a part of the culture of the sea. The words are a record of human activity on the water. The first person to reach the bottom of the Mariana Trench alone did so in 2012. James Cameron piloted the submersible deep-sea Challenger to the Challenger Deep on March 26th of that year. He was the third person to visit the deepest point, following the historic dive of the Trieste in 1960. Cameron spent several hours at the bottom, collecting samples and footage, before returning to the surface. His solo dive was the first of its kind to that depth. The longest single voyage by a sailing ship without stopping was achieved in the 19th century. The Cutty Sark, a famous clipper, was known for its record-breaking voyages between England and Australia. However, the most celebrated long voyage was by the ship that rounded Cape Horn without a single port call. These voyages were grueling and required precise navigation. The first woman to sail solo around the world completed her voyage in 1981. Krystyna Chojnowska-Liskiewicz, a Polish sailor, achieved this feat in a small yacht. Her journey took over 2 years and covered a significant distance. She was the first woman to complete a solo circumnavigation of the globe. It was a quiet but significant achievement in maritime history. The only ocean that touches all other oceans is the Pacific. However, the Southern Ocean is considered to connect all the others through its circumpolar current. The Pacific touches the Arctic, Atlantic, and Southern Oceans at various points. It is the largest and most connected ocean basin. The Atlantic, Pacific, and Indian are all interconnected. The first seafloor mapping using sound was done in 1922. The technology used was an echo sounder, which sent a pulse of sound to the seabed and measured the time it took to return. This was a revolutionary method that replaced the old lead line sounding. It allowed for faster and more accurate mapping of the ocean floor. The Meteor expedition of 1925-27 used this technology extensively. The fastest crossing of the Atlantic by a steamship was set by the SS United States in 1952. The ship made the voyage in 3 days, 10 hours and 40 minutes. This is still the record for a transatlantic crossing by a passenger ship. The ship was designed for speed and was a marvel of engineering. The record has never been broken. The first commercial transatlantic flight by a passenger plane occurred in 1939. The Pan American Airways flight used a Boeing 314 Clipper, which was a large flying boat. The route took passengers from New York to Europe, with stops in between. The flight was a major step in commercial aviation. It reduced the crossing time from days to hours. The largest island in the world is Greenland, which borders the Arctic Ocean. It is almost entirely covered by ice, but it is still a large landmass. Greenland is a territory of Denmark. It is a remote and sparsely populated area. The island is a key part of the Arctic region. The only city in the world built on a coral island is Malé, the capital of the Maldives. The city is densely populated and covers the entire island. It is a unique urban environment. The island is located in the Indian Ocean. The Maldives are a chain of coral atolls. The first recorded use of a diving bell dates to the 4th century BCE. It was used for sponge diving in the Mediterranean. The diving bell was a simple device, like an upside-down bucket that trapped air. It allowed divers to stay underwater for longer periods. The technology was ancient but effective. The oldest known anchor is made of stone and dates back to the Bronze Age. These early anchors were simply heavy rocks with holes for ropes. They were used by ancient mariners to hold their ships in place. The anchors have been found at various archaeological sites. They are a testament to the long history of seafaring. The first oil rig built in the sea was placed in the Gulf of Mexico in the 1940s. This was the start of offshore drilling. The rig was built on a wooden platform in the coastal waters of Louisiana. The oil industry has since expanded to deep water. It was the beginning of a new era in resource extraction. The deepest known point on Earth's surface is the Challenger Deep in the Mariana Trench. It is almost 11,000 meters below the surface. This point is a specific location in the Pacific Ocean. It is a place of extreme pressure and darkness. Only a few submersibles have ever reached it. The greatest total distance rowed solo on the ocean is 43,459 kilometers. This record was achieved by Erden Eruç, who rowed around the world. His journey took nearly 5 years to complete. He rowed across the Atlantic, Pacific, and Indian Oceans. It is a remarkable feat of endurance. The gray whale is known for the longest migration of any mammal. They travel round trips of up to 22,500 kilometers. The journey is from feeding grounds in the Arctic to breeding grounds in Mexico. This is the longest known migration route for any mammal. It is a seasonal journey that covers a vast distance. The blue whale is the largest animal ever known to have existed. It is even bigger than the largest dinosaurs. The blue whale can reach lengths of over 30 meters. Its tongue alone weighs as much as an elephant. It feeds on tiny krill, filtering them through baleen. The deepest dive by a mammal was achieved by the Cuvier's beaked whale. One individual was recorded diving to a depth of nearly 3,000 meters. This is the deepest recorded dive for any air-breathing animal. The same whale also held its breath for over 2 hours. This is a record for both depth and duration. The oldest living vertebrate is the Greenland shark, which can live for hundreds of years. One individual was estimated to be around 400 years old. This makes it the longest-lived vertebrate on Earth. The shark's slow metabolism contributes to its extreme lifespan. It is a remarkable example of longevity. The oldest living invertebrate is a clam named Ming, which was 507 years old. The clam was a quahog found off the coast of Iceland. Its age was determined by counting the growth rings on its shell. The clam was alive during the Ming dynasty in China. Its discovery was a significant event. The highest wave ever recorded was estimated at 100 feet in 1933. This wave was observed in the Pacific Ocean by a naval ship. However, modern measurements are more accurate. The highest wave detected by a buoy was 62.3 feet. Rogue waves can be even larger than these measurements. The fastest swimming fish is widely considered to be the sailfish. They are reported to reach short bursts of speed of up to 110 kilometers per hour. Recent studies suggest a more realistic top speed of around 40 kilometers per hour. The black marlin is another contender for the title. It is a difficult record to measure accurately. The most southerly swim ever performed was in the Bay of Whales in Antarctica. The swimmer was Lewis Pugh, who swam in water that was -1 degree Celsius. The air temperature was even colder at -37 degrees Celsius. He swam 350 meters in only a pair of swimming trunks. It was a test of extreme endurance. The first comprehensive map of the Atlantic Ocean floor was published in 1959. It was created by Bruce Heezen and Marie Tharp. The map revealed the mid-ocean ridge and other features. It was a major advancement in oceanography. The mapping was based on echo-sounding data. The Law of the Sea Treaty entered into force in 1994. This treaty established the legal framework for the oceans. It defines maritime boundaries and resource rights. The treaty was a major achievement of international law. It has been ratified by most countries. The first oceanographic satellite, CSAT, was launched in 1978. It was dedicated to studying the ocean from space. The satellite measured sea surface temperature and wave heights. It demonstrated the potential of remote sensing for oceanography. The first underwater exploration using a bathysphere was conducted in the 1930s. The bathysphere was a steel sphere lowered by a cable from a ship. It allowed humans to explore depths of nearly a kilometer. The first dive was by William Beebe and Otis Barton. The nuclear submarine USS Nautilus reached the North Pole under the ice in 1958. This was the first time a ship had traveled under the Arctic ice. The Nautilus was the world's first nuclear-powered submarine. Its voyage demonstrated the capabilities of nuclear propulsion. The first comprehensive map of the global ocean floor was published in 1977. It was created by Bruce Heezen and Marie Tharp. The map showed the entire global mid-ocean ridge system. It confirmed the theory of plate tectonics. It was a landmark achievement in geology. The Japan Agency for Marine Earth Science and Technology sent the unmanned submersible Kaiko to a depth of 10,978 meters in 1995. This was the first unmanned dive to the deepest point. The submersible collected samples from the ocean floor. It was a major technological achievement. The first autonomous float-based global ocean observation system was deployed in 2000. The Argo floats are used to measure temperature and salinity. There are now over 3,000 floats in the global array. They provide continuous data from the oceans. It is a key system for climate research. The first global exploration of the oceans was carried out by the HMS Challenger from 1872 to 1876. The ship traveled nearly 70,000 miles. The expedition collected data from 361 stations and discovered thousands of new species. It is the foundation of modern oceanography. The expedition set the standard for all subsequent explorations. The longest subsea tunnel in the world is the Seikan Tunnel in Japan, which stretches for 53.85 kilometers beneath the seabed. It connects the islands of Honshu and Hokkaido, with a portion running under the Tsugaru Strait. The tunnel was completed in 1988 after decades of construction. It is a remarkable piece of engineering that allows trains to pass under the ocean floor at depths of up to 240 meters. The deepest shipwreck ever discovered is the USS Johnston, which rests at approximately 6,500 meters below the surface of the Pacific Ocean. The ship was a destroyer that sank during the Battle of Leyte Gulf in 1944. The wreck was found in 2019 by a research vessel, its hull remarkably intact after 75 years at the bottom. The depth is so extreme that only a few submersibles are capable of reaching it. It is the deepest known shipwreck in the world. The oldest living animal ever documented was a clam known as Ming, which was 507 years old when it was discovered. The clam was a quahog, a species of ocean quahog found off the coast of Iceland. Its age was determined by counting the annual growth rings on its shell, much like a tree. The clam was born during the Ming Dynasty in China. Its discovery provided valuable data on ocean history. The longest animal ever recorded is a siphonophore found off the coast of Australia, reaching an estimated 45 meters in length. A siphonophore is a colony of individual organisms called zooids that work together as one animal. It was discovered in a deep-sea canyon and captured on video. The length of this specimen is staggering, far exceeding that of any other animal. The discovery was made by a team of researchers using a remotely operated vehicle. The fastest speed of a surface vessel on water was achieved by a hydrofoil, reaching speeds of over 300 miles per hour. The hydrofoil uses underwater wings to lift the hull out of the water, reducing drag. The record was set in the 1970s and has not been exceeded. This type of vessel is a rare and specialized craft, designed for speed above all else. The largest protected marine area in the world is the Ross Sea region off Antarctica, covering approximately 1.55 million square kilometers. It is a vast area of ocean and seafloor that is protected from commercial fishing. The designation was made to preserve the unique ecosystem of the region. It is a significant step in marine conservation. The area is home to a wide variety of marine life. The shallowest of the world's oceans is the Arctic Ocean, with an average depth of about 1,205 meters. This is significantly less than the other oceans, which are typically thousands of meters deep. The Arctic is also the smallest ocean, covering about 5.4 million square miles. Its shallow depth is due in part to the extensive continental shelves that extend from the surrounding land masses. The Arctic is a cold and icy ocean. The largest tidal power station in the world is located in South Korea, with a capacity of 254 megawatts. The station is built in a tidal barrage, which harnesses the power of rising and falling tides. The electricity is generated as water flows through turbines. It is a significant source of renewable energy for the region. The plant has been in operation for several years. The deepest fish ever photographed was a snailfish at a depth of 8,336 meters in the Mariana Trench. The fish was recorded by a submersible in 2017. It is a small, pale fish with a translucent appearance. The discovery was made during a deep-sea expedition. The fish's ability to survive such extreme pressure is a subject of study. The longest distance swum in open water was a crossing of a significant body of water, achieved by a long-distance swimmer. The distance was over 300 kilometers, swum in the 1960s. The swimmer was propelled by a strong current and careful planning. It is considered one of the greatest feats of endurance swimming. The record has stood for many decades. The highest wave ever recorded was a massive swell, observed in 1933. The wave was estimated to be 100 feet high, but this measurement was based on visual observation. Modern instruments have provided more accurate measurements. The highest wave detected by a buoy was 62.3 feet, a more reliable figure. The record for a rogue wave, measured by a sensor, stands at a slightly lower height. The most isolated island in the world is Tristan da Cunha, a small volcanic island in the South Atlantic. The island is over 2,000 kilometers from the nearest land, which is South Africa. Its population is a few hundred people. The isolation of the island is legendary. It is a remote outpost in the ocean. The oldest known vessel ever discovered is a pine logboat, also known as a dugout, found in the Netherlands. The boat is estimated to be from between 7510 and 8040 BCE, making it over 9,000 years old. It is currently housed in a museum in the Netherlands. The boat was discovered by chance during a construction project. It is a remarkable piece of ancient maritime history. The longest ship ever constructed was the Seawise Giant, which measured 458.45 meters. The ship was an ultra-large crude carrier. It was delivered in 1979 and was the largest vessel ever built. The ship was later scrapped in 2010. The Seawise giant is a record holder that is unlikely to be surpassed. The fastest shipbuilding record was set in 1942 with the construction of the SS Robert E. Peary. The ship was built in just 4 days, 15 hours, and 29 minutes. This record for a vessel over 10,000 tons deadweight was set during the height of World War II. The ship was a Liberty ship, built for the war effort. It is a testament to the efficiency of wartime production. The deepest known sounding in the ocean is the Challenger Deep. The first measurement was taken by the HMS Challenger in 1875. The expedition sounded in 4,475 fathoms, approximately 8,184 meters. This was the first sounding to hint at the extraordinary depths of the Mariana Trench. The trench itself was not fully defined until years later. In 1895, a map published by John Murray designated the area of the Challenger Deep for the first time. The map showed a small area enclosed by a depth curve. The 1899 map refined this further. The maps were based on very few soundings. The Challenger Deep was the deepest known point for many years. In 1899, the USS Nero sounded in 5,269 fathoms, which is about 9,636 meters. This was the deepest depth observed at that time. The record stood for a number of years. The Nero was a converted naval collier. The sounding was part of a survey for a telegraph cable. The RMS Titanic sank in 1912, and the wreck was found in 1985. The discovery was made at a depth of 3,800 meters. The ship lies in 2 pieces on the ocean floor. The site is protected by international law. It is a grave site and a memorial. The shipwreck of the SS Central America was found in 1987. The ship sank in 1857 and was carrying a large cargo of gold. The gold was recovered from the wreck in a major salvage operation. The recovery was a significant event in maritime archaeology. The ship is known as the Ship of Gold. The Endurance, the ship of the explorer Ernest Shackleton, was found in 2022. The ship sank in 1915 after being crushed by ice. The wreck sits at a depth of about 3,008 meters. The ship was remarkably well preserved in the cold Antarctic waters. The discovery was a major event in maritime history. The HMS Erebus and HMS Terror were found in 2014 and 2016. The ships were lost during the Franklin expedition in the 1840s. They were discovered in the Canadian Arctic. The ships are well preserved in the cold water. The discovery solved a long-standing mystery of polar exploration. The CSS Hunley was the first submarine to sink a ship in combat. It was used during the American Civil War. The submarine sank the USS Housatonic in 1864. The Hunley was lost after the attack and was found in 1995. The wreck was raised and is now on display. The shipwreck of the Mary Rose was raised in 1982. The ship had sunk in 1545. The recovery was a major undertaking. The ship is now on display in a museum in England. The wreck is a key part of maritime history. The Vasa was raised in 1961 after sinking on its maiden voyage in 1628. The ship was remarkably preserved in the cold waters of the Baltic. It is now on display in Stockholm. The recovery was a major achievement in salvage. The first oceanographic expedition was the HMS Challenger. It sailed from 1872 to 1876. The expedition covered almost 70,000 miles and collected vast amounts of data. It is the foundation of modern oceanography. The expedition set the standard for all subsequent explorations. The sea level is not a uniform surface across the planet. It rises in some areas and falls in others due to variations in gravity and the rotation of the Earth. This uneven distribution creates what are known as sea surface height anomalies. These subtle bulges and depressions are measurable by satellites. The ocean's surface is a complex, undulating landscape rather than a simple flat plain. The specific amount of salt dissolved in the ocean has remained remarkably constant for millions of years. The processes that add salt, such as river runoff, are balanced by those that remove it, like the formation of evaporite deposits. This dynamic equilibrium is a fundamental aspect of ocean chemistry. The salinity level, around 35 parts per thousand, is one of the most stable properties of seawater. It has been maintained through geological time. The whitecaps that form on waves are caused by the incorporation of air bubbles, not just the reflection of light from the water surface. The bubbles act as tiny optical elements that scatter sunlight, giving the foam its characteristic white appearance. This effect is a purely physical one, based on the interaction of air and water. The presence of whitecaps is a visual indicator of the transfer of energy from the wind to the sea. The color is a result of the light being scattered by the bubbles. The specific sound of the ocean heard inside a seashell is not the sound of the sea itself. It is actually the ambient noise in the room, such as the hum of air conditioning or the distant murmur of voices, resonating within the shell's cavity. The shell acts as a resonator, amplifying frequencies that match its internal shape. This creates the illusion of the ocean's roar. It is a phenomenon of acoustics, rather than a transmission of ocean sounds. The amount of sea salt present in the atmosphere is measurable and plays a significant role in cloud formation. These salt particles act as cloud condensation nuclei, providing a surface for water vapor to condense upon. The process is influenced by wind and wave action. The presence of salt in the air is a key part of the water cycle. It affects the characteristics of coastal weather. The specific temperature of the ocean's surface determines the rate of evaporation. This relationship is a calculable one, governed by physical laws. Warmer water evaporates more quickly, releasing water vapor into the atmosphere. The rate of evaporation is a key driver of the hydrologic cycle. It is a fundamental part of the interaction between the ocean and the atmosphere. The fog that forms near the coast is often composed of tiny salt particles that act as condensation nuclei. The particles, generated by wave action, attract water molecules from the air. This causes the formation of fog droplets. The salt in the fog is a direct link to the sea. It is a common feature of maritime and coastal environments. The exact percentage of nitrogen present in the ocean surface is determined by the air pressure above it. The ocean and atmosphere are in constant equilibrium, with gases dissolving and escaping according to physical principles. The amount of nitrogen dissolved in seawater is a function of the gas pressure. This is a basic principle of chemistry. It explains the composition of the ocean's gases. The exchange of carbon dioxide between the ocean and the air is measured in specific units per square meter. This flux is a crucial part of the global carbon cycle. The ocean acts as both a source and a sink for this gas. The rate of exchange is influenced by factors such as temperature and wind. It is a key parameter in understanding climate dynamics. The ocean absorbs specific frequencies of light, which is why it appears blue. Water absorbs longer wavelengths like red and infrared, while it scatters shorter blue wavelengths. This selective absorption is a physical property of water. The blue hue is a result of the light spectrum. It is the defining color of the open sea. The specific gravity of the surface water is slightly different from that of deeper water. This difference is due to variations in temperature and salinity. Colder, saltier water is denser and tends to sink. The surface water is typically warmer and less salty. This density gradient is a major driver of ocean circulation. The exact time it takes for a single molecule of water to evaporate is a mathematical formula based on physics. The process involves the kinetic energy of the molecules and the surrounding conditions. It is a concept in thermodynamics. The time is not a fixed number, but is highly dependent on environmental factors. The evaporation of water is a fundamental physical process. The concentration of oxygen in the ocean is not uniform. It is highest near the surface, where it is produced by photosynthesis and absorbed from the atmosphere. The oxygen level decreases with depth as it is consumed by respiration and decomposition. The pattern of oxygen distribution is a key feature of ocean chemistry. It creates distinct zones of biological activity. The carbonate system is the primary buffer in seawater. It helps to maintain a relatively stable pH in the ocean. The system involves the balance between carbonate ions, bicarbonate ions, and dissolved carbon dioxide. This chemical equilibrium is vital for marine life. It is one of the most important processes in ocean chemistry. The pH of ocean water is slightly basic, typically averaging around 8.1. This alkalinity is a result of the dissolution of minerals and the buffering action of the carbonate system. The pH is not constant, varying with depth and location. It is a key parameter for marine organisms. Changes in pH can have significant effects on marine ecosystems. The ocean contains an immense amount of dissolved carbon, about 50 times more than the atmosphere. This vast reservoir of carbon is part of the global carbon cycle. The carbon is stored in the form of dissolved inorganic carbon. The ocean plays a major role in regulating atmospheric carbon dioxide levels. It is a key component of the planet's climate system. The bioluminescent glow seen in some areas of the ocean is produced by chemical reactions within organisms. The light is generated when a substance called luciferin reacts with oxygen. This process is catalyzed by enzymes. The light is used for defense, communication, and attracting prey. The phenomenon is common in the deep sea and occurs in some surface species. The ocean is a source of many important chemical elements. Minerals like magnesium, bromine, and iodine are extracted from seawater. The process is used for both industrial and commercial purposes. The ocean is a vast repository of dissolved minerals. The extraction of these resources is a significant industry. The ocean's microlayer is the top millimeter of the sea surface. It is a distinct environment with unique chemical and biological properties. This thin film is rich in organic matter and microorganisms. It is a crucial part of the ocean's interaction with the atmosphere. The microlayer is a focus of ongoing research. The chemistry of the ocean is a complex interplay of physical and biological processes. The elements and compounds are in constant flux. The ocean is a vast and dynamic system. The study of ocean chemistry is essential to understanding the global environment. A single drop of seawater contains about 10,000 different species of bacteria. This remarkable diversity is found in even the smallest samples of ocean water. The bacteria are essential to the marine ecosystem, carrying out functions like nitrogen fixation and decomposition. They are the base of the microbial food web. Their sheer variety is a testament to the complexity of life in the ocean. Viruses in the ocean outnumber all other life forms by a factor of 10 to 1. They are the most abundant biological entities in the sea. These viruses infect bacteria and other microorganisms, controlling their populations. This process, known as viral lysis, releases nutrients back into the water column. They are a key part of the ocean's nutrient cycle. The specific ratio of carbon to nitrogen to phosphorus in plankton is known as the Redfield ratio. This ratio is approximately 106:116.1. It reflects the average elemental composition of marine phytoplankton. The ratio is a fundamental concept in ocean biogeochemistry. It describes the stoichiometry of the ocean's primary production. The smallest known photosynthetic organism is a cyanobacterium called Prochlorococcus. It is less than a micrometer in size, making it one of the smallest living things on Earth. Prochlorococcus is incredibly abundant in the open ocean. It is responsible for a significant portion of the ocean's oxygen production. Its discovery revolutionized the understanding of marine primary production. Dinoflagellates are single-celled organisms that can produce bioluminescence. This light is generated by a chemical reaction within the organism. The glow can be seen at night when the water is disturbed. Dinoflagellates are also responsible for some harmful algal blooms. They are a diverse and ecologically important group of plankton. Diatoms have a specific glass-like shell made of silica, which is unique in the plant world. These shells are called frustules and come in a variety of intricate shapes. The silica is extracted from seawater and used by the diatom to build its outer wall. Diatoms are a major component of phytoplankton. Their shells accumulate on the seafloor, forming a key part of marine sediment. The specific number of bacteria on a piece of ocean plastic is estimated to be in the millions per square centimeter. The plastic provides a surface for bacteria to colonize, creating a new ecosystem known as the plastosphere. These communities are distinct from those found in the surrounding water. They are a relatively new area of study in marine microbiology. The colonization of plastic is a growing environmental concern. Zooplankton are microscopic animals that drift with the currents. They are the primary food source for many fish and other marine animals. Zooplankton includes small crustaceans like copepods and krill. They form a key link in the marine food web, connecting primary producers to larger predators. They are an essential part of the ocean's ecosystem. The specific speed at which a dinoflagellate can swim is about 1 millimeter per second. This is a relatively slow speed, but it is enough for them to move within the water column. The swimming is used to find light and nutrients. The speed is a measured characteristic of these organisms. It is a part of their biology. The dead zone in the Gulf of Mexico is caused by a specific imbalance of nitrogen and phosphorus. This excess of nutrients leads to algal blooms that deplete the oxygen in the water. The low oxygen levels are lethal to many marine organisms. The dead zone forms annually and is a major environmental issue. It is a direct consequence of nutrient pollution. The specific color of bioluminescence in the ocean is almost always blue or green. This is due to the wavelength of light that travels best in seawater. Blue and green light are the least absorbed by water. The organisms that produce light have adapted to this. It is a case of evolution selecting for the most effective wavelength. The exact size of a typical virus in seawater is about 100 nanometers. This is incredibly small, far smaller than most bacteria. Their small size allows them to infect a wide range of hosts. They are a pervasive and influential part of the marine ecosystem. Their discovery has changed the understanding of life in the sea. The ocean contains an immense diversity of microbial life, from bacteria to viruses to tiny plankton. These organisms are the foundation of the marine food web. They are responsible for much of the ocean's primary production. They are the unseen majority of life on Earth. Their study is a key part of oceanography. The discovery of microbial life in the ocean has been a major achievement of science. The techniques used to study them, from microscopy to genetic sequencing, have advanced greatly. The knowledge of these organisms is essential for understanding the ocean's health. They are a vital part of the planet's ecosystem. They are the true rulers of the sea. The ocean's microbial life is a complex and dynamic system. The organisms interact in ways that are only beginning to be understood. They are the engine of the ocean's biological and chemical cycles. The study of this life is a growing field. It is revealing the hidden world of the sea. The abundance of life in a single drop of seawater is a stunning fact. The numbers are almost beyond comprehension. The diversity is immense. The drop is a world unto itself. It is a perfect example of the complexity of the ocean. The Nansen bottle was used to collect water samples at specific depths. It was invented in 1894 by the Norwegian explorer Fridtjof Nansen and refined by his colleague. The device is essentially a cylinder that is lowered on a wire and triggered to close at a chosen depth. This method allowed scientists to capture water from the exact layer they wanted to study, preserving its chemical properties. It was a transformative tool for physical oceanography. The Secchi disc is a white disc lowered into the water to measure visibility. It was introduced in 1865 by Angelo Secchi, an Italian astronomer and scientific advisor to the Pope. The depth at which the disc disappears from sight is a measure of water clarity. This simple device is still used today as a standard method for monitoring water quality. It provides a rough but reliable estimate of the abundance of plankton and sediment. The ROV, or remotely operated vehicle, is a tethered underwater robot used for exploration. It is connected to a surface ship by a cable that transmits power and data. The vehicle allows researchers to explore the deep ocean without leaving the deck. It is equipped with cameras, manipulator arms, and other sensors. The ROV is a workhorse of modern oceanography. The AUV, or autonomous underwater vehicle, operates without a cable, following a programmed path. It is a free-swimming robot that can cover vast distances. The AUV carries its own power source and navigates using sonar and other instruments. It is used for mapping the seafloor and collecting data in remote areas. The AUV is a key tool for deep-sea research. The specific frequency used in sonar to map the seafloor is typically around 12 kHz. This is a specific acoustic frequency used for surveying the ocean bottom. The sound waves bounce off the seafloor and return to the ship, providing information about depth and shape. The frequency is chosen to balance range and resolution. It is a standard parameter in marine geophysics. The altimeter on a satellite measures sea surface height by bouncing a radar signal off the water. The instrument provides a global view of the ocean's surface. By measuring the time it takes for the signal to return, it creates a map of sea surface topography. This data is essential for understanding ocean currents and climate. The satellite altimeter is a powerful tool. The CTD instrument measures conductivity, temperature, and depth, and is standard on all research ships. It is the primary instrument for collecting vertical profiles of the water column. The data from the CTD reveals the physical structure of the ocean. It is used to identify water masses and study circulation. It is a fundamental tool for oceanographic research. The baited remote underwater video is a camera system used to count fish without capturing them. The system consists of a camera, lights, and a bait bag. It is deployed on the seafloor to attract and film marine life. The footage is used to estimate fish populations and biodiversity. It is a non-invasive method of surveying marine life. The specific material used for deep-sea cables is typically polyethylene, coated in steel for protection. These cables are the backbone of the global internet. They are designed to withstand the immense pressure of the deep ocean. The polyethylene insulation is lightweight and resistant to corrosion. The steel armor protects against abrasion and damage. The Argo network is a group of over 3,000 drifting floats that measure the temperature and salinity of the ocean. The floats are deployed across the globe. They descend to a depth of 2,000 meters and drift with the currents. Every 10 days, they rise to the surface to transmit their data. The Argo network is a key component of the global ocean observing system. The specific type of battery used in deep-sea instruments is often lithium, designed to withstand high pressure. Lithium batteries have a high energy density, which is essential for long deployments. They are housed in pressure-resistant casings. The choice of battery is a critical factor in the design of underwater instruments. They must operate reliably for months or even years. The hydrophone is an underwater microphone, first used to detect icebergs after the Titanic disaster. The device converts sound waves into electrical signals. Hydrophones are now used for a wide range of purposes, from studying whale calls to detecting seismic activity. They are a key tool for listening to the ocean. The technology has advanced significantly since its first use. Sound travels about 4 times faster in water than in air, at approximately 1,500 meters per second. This is a fundamental physical property of the medium. The speed is determined by the density and compressibility of water. This high speed allows sound to travel great distances underwater. It is the basis for sonar and underwater communication. The specific depth where sunlight stops penetrating is called the aphotic zone, beginning at about 1,000 meters. Above this depth is the photic zone, where enough light exists for photosynthesis. The aphotic zone is a realm of permanent darkness. The transition is a gradual one, with light diminishing with depth. This boundary defines the vertical structure of the ocean's ecosystems. Water is densest at about 4 degrees Celsius, which is why the deepest parts of the ocean are often this temperature. This is an unusual property of water, as most substances are densest when solid. The density maximum occurs above the freezing point. This causes water to sink to the bottom, creating a stable, cold layer. It is a key factor in ocean stratification. The Sofar Channel is a deep-sea layer where sound travels great distances with minimal loss. It is a region of minimum sound speed, acting as a waveguide. Sound waves are trapped in this channel and can travel thousands of kilometers. The Sofar Channel was discovered in the 1940s and was used for locating downed aircraft. It is a remarkable feature of ocean acoustics. The specific pressure at the bottom of the Mariana Trench is over 1,000 times the atmospheric pressure at sea level. This immense pressure is a defining characteristic of the deep ocean. It is a physical force that shapes the biology and geology of the deep sea. The pressure is a constant presence in the deep ocean. It is a fundamental condition of that environment. The ocean's surface tension is higher than that of fresh water, affecting how small insects float. The surface tension is a property of the liquid's surface. The salt content of seawater increases its surface tension. This allows small organisms to rest on the surface. It is a subtle but significant physical difference. The index of refraction of water causes objects in the ocean to appear differently than they are. This optical property bends light as it passes from water to air. The effect makes objects seem closer and larger. This is why underwater scenes appear distorted. It is a fundamental principle of optics. The specific speed of a surface wave is determined by its wavelength, not its height. In deep water, longer waves travel faster. This is why waves from distant storms arrive before the storm itself. The speed is a function of the wave's period. It is a standard equation in wave mechanics. The Coriolis effect causes ocean currents to turn to the right in the northern hemisphere and to the left in the southern. This is due to the rotation of the Earth. The effect is a major driver of ocean circulation. It influences the paths of currents and the formation of gyres. The Coriolis effect is a fundamental force in geophysics. The specific amount of oxygen dissolved in seawater is higher in colder water. This is a basic principle of gas solubility. Cold water can hold more dissolved gas than warm water. This is why polar regions are rich in oxygen. The oxygen content is a key factor in marine life distribution. The thermohaline is a specific layer where the temperature drops rapidly with depth. It is a region of the ocean where the temperature gradient is steep. The thermohaline is a barrier to vertical mixing. It separates the warm surface layer from the cold, deep water. It is a permanent feature of the ocean. The specific density of seawater is about 1.025 grams per cubic centimeter, compared to 1.0 for fresh water. This difference is due to the dissolved salts. The higher density of seawater affects buoyancy and circulation. It is a fundamental property of the ocean. The density is a key parameter in oceanography. The ocean's surface is the boundary between the atmosphere and the hydrosphere. This interface is a critical zone for the exchange of energy and matter. The processes that occur here are central to the global climate system. The interaction of air and sea is a dynamic one. It is a key area of study in oceanography. Light penetration in the ocean is limited by absorption and scattering. The blue part of the spectrum penetrates the deepest. This selective absorption gives the ocean its color. The depth of light penetration varies with water clarity. It is a key factor in marine biology. The ocean's surface temperature is influenced by solar radiation, wind, and currents. The temperature varies by latitude and season. The surface temperature is a key factor in climate and weather. It is measured by satellites and buoys. The data is essential for understanding the ocean. The movement of water in the ocean is driven by wind, tides, and density differences. These forces create currents that transport heat and nutrients. The currents are a major factor in the global climate. They are a fundamental part of the ocean's dynamics. The patterns of flow are well studied. The study of the interface between air and water is a multidisciplinary field. It involves physics, chemistry, and biology. The understanding of this interface is essential for climate science. The ocean's interaction with the atmosphere is a complex process. It is a key area of research. The ocean is a vast and dynamic system. The physics of its interaction with the air is a fundamental part of its behavior. The exchange of energy and matter shapes the planet. The study of this interface is a core part of oceanography. The ocean and atmosphere are intimately connected. The ocean absorbs about 31% of the carbon dioxide released into the atmosphere. This is a significant portion of the total emissions. The absorption occurs at the sea surface, where the gas dissolves into the water. The process is driven by the difference in concentration between the air and the sea. The ocean is a major sink for this greenhouse gas. The specific rate at which the ocean has been absorbing heat is measured in zettajoules per decade. This unit of measurement reflects the enormous scale of the energy involved. The ocean has absorbed more than 90% of the excess heat from climate change since the 1970s. The amount of heat stored is a staggering figure. The ocean is a vast reservoir for thermal energy. The El Niño event changes the sea surface temperature in the Pacific by a specific amount of degrees Celsius. The warming can be several degrees above average in the central and eastern tropical Pacific. This shift in temperature has far-reaching effects on global weather patterns. The event is a natural part of the climate cycle. It is a well-studied phenomenon with predictable consequences. The Little Ice Age was a specific period of cooling that occurred from about the 14th to the 19th century. It may have been influenced by ocean circulation changes. The cooling was most pronounced in the North Atlantic region. The causes are complex and not fully understood. The period was marked by colder winters and shorter growing seasons. The specific amount of sea ice in the Arctic is measured in millions of square kilometers annually. The ice cover expands in winter and contracts in summer. The annual minimum extent is a key indicator of the state of the Arctic. The measurement is made by satellite. The data shows a long-term trend of decline. The ocean stores more than 90% of the excess energy from climate change. This energy is in the form of heat. The warming of the ocean is a major consequence of the increase in greenhouse gases. The heat is stored in the upper layers of the ocean. This storage is a key factor in the planet's energy balance. The specific rate of sea level rise is measured in millimeters per year. The rate is not constant. The rise is due to thermal expansion of the ocean and melting of land-based ice. The measurement is made by tide gauges and satellites. The rate has been increasing over recent decades. The Gulf Stream affects the climate of Western Europe, but its flow rate fluctuates by a specific percentage. The current transports warm water from the tropics to the North Atlantic. This warming influence is a key reason for Europe's relatively mild climate. The flow rate varies over time. The fluctuations are a subject of ongoing study. The specific amount of phytoplankton in the ocean has been measured by satellite since 1979. The phytoplankton are the base of the marine food web. They also play a role in the carbon cycle. The satellite measurements track the concentration of chlorophyll. The data reveals seasonal and interannual variability. The salinity of the surface ocean is affected by the amount of precipitation and evaporation. Regions with high evaporation, such as the subtropics, tend to have higher salinity. Regions with high rainfall, such as the tropics, tend to have lower salinity. The salinity is a key parameter in oceanography. It affects the density of the water. The specific rate of vertical mixing in the ocean is measured in square meters per second. This mixing is driven by winds and currents. The process is important for the transport of heat and nutrients. The rate varies by location and depth. It is a key parameter in ocean models. The ocean conveyor belt is a specific term for the global thermohaline circulation. This circulation is driven by differences in temperature and salinity. It is a slow, deep current that connects all the oceans. The conveyor belt transports heat around the globe. It is a major component of the climate system. The ocean's role in the climate system is a central one. It is the largest reservoir of heat and carbon. The ocean's dynamics are a key part of the Earth's climate. The interaction of the ocean and atmosphere is a complex one. The study of this interaction is essential for understanding climate. The ocean is a key component of the global water cycle. It is the source of most atmospheric water vapor. The evaporation of water from the ocean is a major driver of the cycle. The water vapor is transported by winds and falls as precipitation. The ocean is a fundamental part of the planet's hydrology. The ocean's temperature and salinity are the primary drivers of its circulation. The density of seawater is determined by these two factors. The circulation transports heat and nutrients. It is a system that is in constant motion. The ocean's circulation is a major factor in the global climate. The study of the ocean's role in climate is a multidisciplinary field. It involves oceanography, meteorology, and climate science. The understanding of the ocean is essential for predicting climate change. The ocean is a major component of the Earth's system. The research is ongoing. The ocean is a vast and powerful force. Its influence on the climate is undeniable. The ocean is a key part of the Earth's system. The understanding of the ocean is essential for the future. The ocean is a source of wonder and a subject of study. The exact weight of all the water in the ocean is approximately 1.4 times 10 to the 21st power kilograms. That is a number so large it is difficult to comprehend. It is a figure that represents the total mass of the global ocean. The weight is a fundamental measurement of the planet's hydrosphere. It is a number that is both precise and almost unimaginable. The specific volume of the Pacific Ocean is greater than the volume of all land above sea level. This means that the Pacific alone contains more water than the total volume of all the continents and islands. The comparison is a striking one. It emphasizes the sheer scale of the largest ocean basin. The Pacific is a vast repository of water. The number of islands in the Pacific Ocean is estimated to be over 25,000. This is more than any other ocean. The islands range from tiny atolls to large landmasses like New Zealand. The count is an approximate one, as new islands can form from volcanic activity. The Pacific is a scattered archipelago of countless islands. The specific length of the world's coastlines is approximately 620,000 kilometers. This is the total length of the shoreline of all the continents and islands. The measurement is approximate and depends on the scale used for mapping. The coastline is a complex and intricate feature of the Earth's surface. It is a boundary between land and sea. The exact number of fish caught globally is over 90 million tons per year. This is a vast quantity of marine life. The figure is an estimate and varies from year to year. The fishing industry is a major economic activity. The catch is used for food and other purposes. The specific thickness of the ocean's surface film, known as the microlayer, is about 1 millimeter. This is the very top layer of the ocean. It is a unique environment with distinct chemical and biological properties. The microlayer is a crucial part of the ocean's interaction with the atmosphere. It is a very thin but important boundary. The amount of plastic in the ocean is measured in millions of tons, but it is a statistical estimate. The exact figure is difficult to determine. The plastic is distributed throughout the water column. It is a major environmental concern. The estimate is based on models and limited data. The specific pH of ocean water is slightly basic, averaging around 8.1. This is a measure of its acidity. The pH is not constant and varies by location and depth. It is a key parameter for marine life. The pH of the ocean is a subject of ongoing study. The exact number of species in the ocean is unknown, but new ones are described each year. The ocean is still largely unexplored. The discovery of new species is a regular occurrence. The total number of species is estimated to be in the millions. The ocean is a vast reservoir of biodiversity. The specific rate of evaporation from the ocean is about 1 meter per year on average. This is the total amount of water that evaporates from the surface. The rate varies by location and season. The evaporation is a major part of the water cycle. It is a key process in the Earth's climate system. The amount of water vapor in the atmosphere is roughly the same as the volume of the ocean's surface layer. This is a measure of the amount of water in the air. The water vapor is a greenhouse gas. The amount in the atmosphere is a small fraction of the total water on Earth. It is a key part of the climate system. The exact time it takes for a single molecule of water to travel the entire ocean circuit is about 1,000 years. This is the time for a drop of water to complete the global circulation. The journey is a slow one. The water moves through the deep ocean and back to the surface. It is a long-term cycle. The ocean is a vast and ancient system. It contains a wealth of water and life. The ocean is a fundamental part of the planet. It is a source of wonder and a subject of study. The ocean is a place of quiet and immense scale. The ocean's smallest details are a testament to its complexity. The numbers and measurements are precise. The ocean is a system of immense scale and fine detail. It is a world within a world. The study of the ocean is a journey into the unknown. The ocean is a place of peace and quiet. It is a place of endless motion. The ocean is a constant presence on the planet. It is a part of the Earth's identity. The ocean is a source of calm. The facts about the ocean are a collection of small details. They are the margins of the sea. They are the overlooked and the understated. They are a record of the ocean's story. The facts are a quiet testament to the sea. And so we arrive at the end of these collected margins. The water continues its slow circuit, the same way it has for millennia, indifferent to the facts we have gathered and the ones we have surely missed. That was the intention all along, to let the details blur at the edges, to let the specifics dissolve into something softer. The ocean does not need us to understand it. It simply is. If you drifted off somewhere between the depths and the measurements, that is exactly as it should be. The numbers were not for keeping. They were for passing through. They were for filling the space between waking and sleep, for occupying the mind just enough to let go. We will leave you with one final piece of trivia, the smallest and quietest of them all. The specific weight of a single drop of seawater is approximately 0.025 grams. That is about the weight of a grain of sand. It is nothing and everything at once. The ocean is made of these tiny, singular drops, each one unremarkable on its own, but together forming something vast and unknowable. The waves will keep moving, the tides will keep turning, the currents will continue their slow, eternal drift, and you, lying in the dark, are part of that same motion. The ocean is out there, but here, in this room, there is only the quiet. Let the facts fall away. Let the water be water. Let yourself be still. Good night.